The IMS Gate Academy Gate Score Booster session of digital circuit subjects. Okay, this is the first session regarding digital circuit subject Gate Score Booster session. This session is common for 4 branches: EC, Electrical, Instrumentation, Computer Science. Whoever write in the Gate 25 exam and whoever belong to these 4 branches, EC, Electrical, Instrumentation, Computer Science, this session is going to help a lot for all the 4 branch students. And today and tomorrow, in these 2 sessions, we are going to discuss the variety of questions which are very much important for your coming GATE exam regarding digital circuit subject. Okay, in today's session, I am going to focus on the first 3 chapters of digital circuit subject. Those are number systems and codes, Boolean algebra and K-maps, and logic gates implementation. Right? Whoever by this time thoroughly prepared regarding this particular subject, and whoever want to check their confidence regarding this particular subject, whether you have thoroughly prepared, whether you are ready for your coming GATE exam regarding this particular subject or not. If you want to test yourself or if you want to check your knowledge, this session and tomorrow's session is going to help a lot for all these 4 branch students. Yeah, good evening Anish, good evening Matan, very good evening one and all. Okay, so all of you kindly like this particular session and share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session. And whoever visiting our YouTube channel very first time, so kindly subscribe our YouTube channel and then click on the bell icon so that you will be getting instant notifications whatever the upcoming videos which we are doing in our YouTube channel, either live sessions or recorded, whatever we are doing in our YouTube channel, all the notifications and updates you will be getting instantly. Okay, you won't miss even single video. Right? All of you kindly like and share this video link quickly with all of your friends so that all those students also can attend this session live and they also will get benefited from this particular session. Okay, so before going to, like, just I am giving one update. Whatever the questions I am discussing here, for every question I will be showing the question and I will be giving some time for everyone. All of you can give a try and whatever the answer you are getting, you can mention the chart. Okay, for every question I will be giving some time. I will keep the timer on the screen also just for reference. After that I will be discussing the whether your answer is correct or not and then explanation for that question as well. Okay, right. I hope all of you are ready for the session. Okay, right. So this is the first question regarding digital circuit subject regarding gate score booster session. Okay, right. All of you give a try. This is a question related to addition operation. Yeah, this question is MSQ. This is a very important. This question is MSQ. Either one option or more than one option can be correct. Yes, very good Anish, very good Medha, Nagabhushan. Yes, very good. All of you are getting correct answers. For this question, two choices are correct, C and D. Very good. See here in this question, they have given two numbers, 2, 4 and 1, 3, and these two numbers, 2, 4 and 1, 3, both the numbers belong to base 5. Base 5, and here you are supposed to perform addition operation. That means the sum of these two numbers in base 5. And the resultant number, here if you observe the choices, two choices you are having in the decimal number system, two choices you are having in the base 5. Okay. Right. So first of all, tell me, in base 5 number system, for a single digit, what is the maximal that we can represent? In base 5 number system, for single digit, what is the maximum value we can represent? Starting value is 0. What is the maximum value? 4. Yes or no? 5 minus 1 is nothing but 4. That means whenever you are performing addition of two numbers, definitely you are performing digit by digit. If you are getting resultant sum less than 5, then you can easily represent with the help of single digit. But whenever it exceeds 5 or it exceeds 5, that time you require one more additional digit, that is nothing but carry. That is the important observation. So in base 5 number system, when you are having two digits, the corresponding positional weights are 5 power 0, 5 power 1. So whenever you require one more additional digit, always we will represent carry as 1, but equivalent value of that particular carry is nothing but base of the number system. 5 power 1 into 1, that is nothing but 5. So this is a very, very important conclusion point. Now, once if you know this property, after that you can easily solve this question. So here we are having 2, 4 and then 1, 3. Both belongs to base 5 number system. Now 4 plus 3, that is nothing but 7. 7. It is exceeding 5, right? 4 plus 3 is 7. So this 7 in base 5 we can represent as, just now only we have given the conclusion, our hint point. Whenever we require additional digit, we are representing carry, but equivalent value of carry is base. That means you have to write this number as base plus something. Here base is 5, you are adding with 2, then you are getting 7. That means here we require two digits, 1 and 2 belongs to base 5. Here in this case, sum digit is 2, carry digit is 1, right? Sum digit is 2, carry digit is 1. Now you can perform the addition. 1 plus 1 is 2, 2 plus 2 is 4. 4 we can represent with the help of single digit, you can directly represent. So that means 4 to base 5, that is there in option C. Okay, with the help of this one, we are getting option C as the correct one. Option C as the correct one. Now the moment you got option C correct, for this number, you can convert into decimal by placing the positional weights. Just now only we have told 5 power 0, 5 power 1, exactly the same procedure you can apply here in order to get the corresponding decimal equivalent. 5 power 0, 5 power 1. 5 into 4, that is 20, dash step I am writing, plus 5 power 0 is 1 into 2, that is 2. 20 plus 2, that is 22. Okay. So with the help of this one, we are getting option D as the correct one. I hope it is clear for everyone. For this question, two choices are correct, option C and option D. Okay, right. If you are having any doubt while we are discussing any question, right, regarding that particular question, regarding any terminology or regarding part of the solution, if you are having any doubt, you can mention in the chat, I will clarify. Okay, I hope it is clear for everyone regarding this question. Okay. Whoever not enrolled at our IMS GATE Academy and whoever targeting for GATE 25 exam and in order to get very good marks, so I am recommending for all those students, you can enroll for the Test Series Plus program, and whoever already enrolled at our IMS GATE Academy, kindly share this valuable information with all of your friends and juniors whoever targeting for GATE 25 exam and whoever they are doing either self-learning program or they might have taken coaching any other institute, no issue. But whatever the preparation they have done till now, if they want to check regarding their confidence level or knowledge with respect to the subjects which they are preparing for the coming GATE exam, so I am recommending those students, they can enroll for the Test Series Plus program, because whoever enrolling for this particular program, you will be getting 130 plus online tests for every subject. You are having the chapter level test, and then subject level test also we are having, like basic test and then advanced test and then multi-subject test. Okay, and even we are having all the mock tests as well. All these tests together you are having 130 plus tests, and in addition to that you are getting 33 years previous year GATE question booklet regarding technical subjects. Suppose if you are from EC, you are getting EC booklet regarding all the technical subjects, and along with that regarding maths and general aptitude, you will be getting last 33 years GATE previous year question booklet regarding 6 branches: EC, electrical, instrumentation, computer science, mechanical, civil. Okay, so that means you are getting great, you can do good number of practice regarding the previous questions regarding your technical subjects, and not only that, maths and GA, because if you solve good number of previous year GATE questions, you will be getting good command over the standard models. Definitely that confidence will make you in order to get very good rank in the upcoming GATE exam. And in addition to that, this test series also going to help a lot. Okay, because when you are attempting in the test, so you are getting the exam atmosphere and you are cross checking whatever the questions you are attempting in a given exam, whether you are able to maximize your score or not. Okay, right. In addition to that, you are getting all these features also. So whoever interested for this particular Test Series Plus program, regarding the link already provided in the description of this particular video, so all of you kindly fill that particular form and you will be getting 20% discount on Test Series Plus program. Okay, this is the limited time offer is there, so all of you kindly share this valuable information with all of your friends and juniors. Okay, right. And one more important update, whoever want to prepare currently, whoever second year BTech or third year BTech, and whoever want to target GATE 26 exam or even GATE 27 exam, so you people can enroll for the live online program at our IMS GATE Academy. So we are having 800 plus hours of live online classes. In each and every class, whoever faculty discussing regarding that particular subject, so every faculty will be discussing the concepts from basic level to the application level, and we are going to cover even the GATE questions and practice questions from the basic level to the application level, even in terms of difficultiness as well, easy, moderate and toughness. Okay, and in addition to that, for every subject we are providing the theory book and then exercise book. In exercise book you will be having like level 1, level 2, level 3 questions, and in addition to that you are having GATE previous year question booklet along with the solutions. Okay, and then 12 my plan sessions we are having, and then 130 plus online tests. Okay, and whoever already joined at our IMS GATE Academy and whoever got benefit from our classes, either live online or physical classes or hybrid program, you people can share your valuable experience at our IMS GATE Academy with your friends and juniors, so that whoever want to prepare GATE 26 or 27 upcoming year's GATE exam, so you people can share this valuable information with them, and they can click on the link which is provided in the description of this particular video. Our counselors will discuss in detail about our live online program. Okay, right. Okay, next question, all of you give it, right? I hope all of you share whatever the 2 important updates I have told just now to all of your friends and juniors. Okay, right. Next question, all of you give it, right? Yeah, Medha, like for this number, what is the decimal equivalent you got? Yes, very good, Anish, very good. See, here in this question, the most important thing, here we are asking not equivalent, not equivalent. This is a very, very important, not only in this subject, in any subject, when you are attempting the GATE question, read the context of the question. In some questions, they will be asking among the following, which one is the correct, or among the following, which one is incorrect, or equivalent or not equivalent. The wording is very important. In this question, you are having 110 base 5, that is one number, and for that number, you are having like 4 choices: decimal, octal, binary, hexadecimal. Among these 4 choices, which number is not equivalent for this given number? That is the correct option. That is a very interesting one. Right. So first of all, I am considering the given number 110 base 5. So just now only we have discussed, in order to get the corresponding decimal number, we have to put the positional weights in powers of the base. Yes, you can put the positional weights in powers of the base. Here base is 5, 5 power 0, 5 power 1, 5 square. Okay, you can multiply every digit with the corresponding positional weight and then you can add. Yes, very good, Phoenix. What is your name? Yeah, 5 square is 25 into 1, that is 25, plus 5 power 1 is 5 into 1, that is 5. Then 5 power 0 is 1, 1 into 0 is 0. 25 plus 5, that is 30. That means whatever the number here in option A you are having, that is the equivalent one. That is the equivalent one. But here we have to find out not equivalent one. Okay, right. Now regarding option B, you are having octal number. Okay, see, if you want to verify, you can do based on your convenience. Whenever you are having MCQ or MSQ, you are having 2 ways. Like forward approach is what? According to the context of the given question, you can go. You can find the corresponding solution. That is one approach. Or since you are having choices, from the choices you can verify whether the given number is equivalent or not. In that manner also you can do. Okay. Say for example, for the time being, I am considering option B, whatever you are having, like 36 base 8. Okay. Since just now I have discussed this approach, I am just verifying in the same approach. Okay. In this case, positional weights will be 8 power 0, 8 power 1, right? So 8 3s are 24 plus 8 power 0 is 1 into 6. Yes, I am getting the same number, 30. Yes, this is also equivalent, 30. Okay. Option A, option B, both are equivalent for the given number. Okay, right. If you want, you can do other way, that since you got 30 as a decimal number, you can perform repeated division operation in order to get the corresponding octal number. Okay, right. Now, since option B is matching, option B is the equivalent, so from octal to binary, we can get just by representing every octal digit with how many bits? All of you tell me. Every octal digit, how many bits we have to represent in binary? 3 bits. Yes or no? 3 we can represent as 0 1 1. Then 6 we can represent as 1 1 0. And here the leftmost bit 0 is insignificant, we can neglect. Then you are having 4 1s and then 0. Yes, 4 1s and 0 we are having. So that means whatever option A, option B, option C, those are equivalent for the given number. That means straight away we can choose D. Okay. Yes, very good. Straight away we can choose D as the correct answer for this question. Is there any doubt why D is not equivalent? If any of you are feeling option D is also equivalent, okay, if any of you are having the doubt, you can mention in the chart, I will discuss. See, just for reference, you can observe from here only. Like, you got the binary number. If you want to get the hexadecimal, we have to do the grouping of 4 bits. We have to do the grouping of 4 bits. See, whatever the binary number here we got, I am considering that one once again, like 4 1s and 0. This is the number we got. Okay. Now, if you want to get the corresponding hexadecimal, we have to do the grouping of 4 bits. Here, 3 bits are shortage. You can put simply zeros. 0001 is nothing but 1, then 1110 is nothing but E, 1E base 16, 1E base 16, but here you are having F0 base 16. Okay, since it is not equivalent, that is the correct answer for this question. Option D is the correct answer for this question. Okay, I hope it is clear for everyone. Next question, very interesting one. This is the question regarding 2's complement. Okay, this is a very, very important concept for all the 4 branches: EC, electrical, instrumentation, computer science. Okay, in this question you are having A number, B number, and here you are having 4 choices, among which 2 choices regarding A plus B, 2 choices regarding A minus B. So definitely you can expect among these 2 choices at most 1 choice can be correct. Among these 2 choices at most 1 choice can be correct. All of you give it a try. Some of you can try for among A and B which one is correct. Some of you can try for among C and D which one can be correct. Okay, meanwhile I will write the given numbers. So here A is 0101 and then 1000, and similarly B is another number 1101 and then 0101. Now with respect to option A, option B, you are having addition operation, right? Addition operation we have to perform. That means A plus B. A plus B. Yeah, Medha, you can cross check once. So now just perform the addition. 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1, 2. Sum is 0, carry is 1. So here after performing addition you are getting 1. Then 1 plus 1, sum is 0, carry is 1. Here 1 plus 1, sum is 0, carry is 1. So after performing addition of these 2 numbers, since you are getting resultant answer like this, and now if you observe option A here, 10010, then 1101. Since this is there in option A, most of the time few students will do silly mistake here. They will choose option A will be correct. But here what is the most important? What is the most important thing? Whatever the A number, B number they have given, both are represented in 2's complement form. The wording is very important. Both are represented in 2's complement form. Right. Now tell me, here you are performing this number, is it positive number or negative number? All of you confirm. Similarly, this number, is it positive or negative? All of you just confirm. Here sign bit 0, that indicates positive number. Here sign bit 1, it indicates negative number. Right. So, yes, very good Anish, very good. Here sign bit 0 indicates positive number, sign bit 1 indicates negative number. So you are adding one positive number with negative number. That means what actually we are performing? you are adding post number with net number. That means actually we are performing subtraction, right? That is very, very important. Okay, so when you perform the subtraction, whenever you are performing subtraction, whatever the bits here you have considered, those bits are more than sufficient. Those bits are more than sufficient. You no need to require any extra bit. That means whatever, after performing addition of two numbers like this, if the sign bits are not same, if you are getting leftmost side 1, that one you can ignore. That one you can ignore. Now whatever the answer you got, that is the correct answer. That's all. So regarding that one, you are having option B. So as of now, among A and B, we have decided B is the correct one. Is it clear, Medha? This is a very, very important concept. All of you confirm whether it is clear or not. If you are having any doubt, you can mention in the chat. I will clarify. Okay, right. Now option C, option D, you are having A minus B. Okay, so whatever the B number you are having, I am copying once again. 1101, 1101, then 0101, 0101, right? So here I want minus B. That means for B, if you apply 2's complement, then it will become minus B. 2's complement of B is nothing but minus B. Okay, by using two-step procedure you can apply. Here from right to left till you are getting first time 1, you can copy those bits. Here starting bit itself is 1, so you can copy as it is. The moment first step is done, remaining bits you can apply 1's complement. So here you are getting 1 0 1 0 1 0 0. Right, this overall number is minus B, or in other words, here B number is what? Negative number, just by observing sign bit. When you apply 2's complement, net number will become what? Positive number. Now you can observe here sign bit. Yes, it is a positive number. Okay, this is minus B, and A number I am copying as it is. A number 0101, then 1000, 1000. So now I am adding these two numbers. A plus of minus B, that is nothing but A minus B only. Okay, I hope it is clear for everyone. Okay, now just like here, you can perform the addition. 1 plus 1, 2. Sum is 0, carries 1. Sum is 0, carries 1. Sum is 0, carries 1. Here you are getting. Now tell me, the moment you are getting like this, whether this is correct or not. Medha, you can confirm now. Even other students also, whoever got wrong earlier for this question, those students can confirm now whether this is the final answer or whether we have to do any adjustment. If you are able to answer for this question correctly, at least you are on track. Even though you might have done the silly mistake here, no problem, but I am giving second chance here. Whether this is the final answer or whether we have to do any adjustment. Yeah, good evening, Tarun. Yes, very good, Medha, very good. Here you can observe sign bit 0, positive number. Here also sign bit 0, positive number. You are adding two positive numbers. Whenever you are adding two positive numbers, ideally answer should be positive. Similarly, whenever you are adding two negative numbers, ideally answer should be negative. Here you are adding two positive numbers, but if you consider the same number of bits, because of this bit 1, it seems to be your answer is negative. Whenever you are adding two positive numbers, never you will get net number, right? So that means here overflow occurs. We have to consider one more additional bit. That bit here in this case, since both are positive, you can keep that leftmost bit as 0. That's all. Now this is there in option D. Okay. So for this question, two choices are correct. With respect to a plus b, option B is correct. With respect to a minus b, option D is correct. Okay, this is a very, very important concept for all the 4 branches: EC, electrical, instrumentation, computer science. Even though every student thoroughly learnt this particular concept, but whenever you are getting the question like this, still majority of the students are doing the silly mistake. No issue at all, but at least whatever the learning point is there, that learning point note down in your notebook. Definitely, at least from now onwards, whenever you are attempting these kind of questions, definitely you can overcome wherever you are, in general you are doing a silly mistake regarding this concept. Okay, right. Yeah, next question, all of you give it a try. So this question is MSQ. Which are the following is or correct? This question is MSQ. This topic, data representation, is very important for all the 4 branches. All of you give it a try. The wording is very important. So here you are having 4 choices. Among these 4 choices, whichever are correct according to the notation they have mentioned, you can choose them as the correct one. So all of you confirm A and B, whether those are correct or wrong. A and B, whether those are correct or wrong. Yes, very good, Anish, very good. See, here the most important thing, whenever the word representation is there, okay, yes, very good, Phoenix, yeah. Whenever the word representation is there, okay, if you are having positive number, sign bit should be what? Sign bit should be 0, that's all. Sign bit should be 0. Okay, and similarly, whenever you are having negative number, sign bit should be 1. Whether they are mentioning 2's complement form or 1's complement form or sign magnitude form, irrespective of that, because the sign magnitude form, 1's complement form, 2's complement form, we are representing for the sign numbers. Okay, whenever the word representation is there, okay, if it is positive number, sign bit should be 0. If it is negative number, sign bit should be 1. But here you are having what? You should have 0, but you are having 1. So that means this is not correct. Similarly, here you should have 1, but here you are having 0. So this is also not correct. This is also not correct. Now, here also the word representation is there. Okay, here negative number is there. Yes, sign bit is 1. Yes, up to here it is correct. Up to here it is correct. That is the first indication. Okay, whether you are having 2's complement, 1's complement, sign magnitude, irrespective of that, whatever the sign here you are having, accordingly the sign bit should be there. That is the first observation. Now, after this, suppose if it is a positive number, the moment sign bit you are getting 0, remaining bits simply give the magnitude. Whatever you are getting as per sign magnitude, the same answer will applicable in 1's complement and 2's complement as well. Okay, right. Now, just observe here. Now, coming for this particular option C, you are having sign magnitude. Okay, so when you are using sign magnitude, the leftmost bit we are reserving for sign bit, the remaining bits we are reserving for magnitude. So for 15 we can represent as, yes, 4 ones. That is correct. So that means option C is the correct one. Option C is the correct one. Suppose if they're asking 2's complement representation of minus 15 or 1's complement representation of minus 15, if they're asking like that, consider the post number. First of all, consider the magnitude 15. After that, represent plus 15 in sign magnitude form. For that number, apply 1's complement or 2's complement according to like your requirement. If you want 1's complement representation, you have to apply 1's complement of post number, it will become negative. If you want 2's complement form, you can apply 2's complement to the post number, you are getting negative number in the 2's complement. Okay, right. Now the option D, they are asking smallest integer that we can represent in 2's complement form using 6 bits. Okay, it is very simple. If you know the formula, that is fine, you can substitute the n value 6, but even I am giving the shortcut also. Say for example, here the context is with respect to 2's complement form and using 6 bits. Okay, so first of all, represent 6 bits. 1, 2, 3, 4, 5, 6. Okay, right. 6 bits are there. Now put the positional weights in powers of 2. Okay, since you are having 6 bits, you have started positional weight 2 power 0. So the maximum positional weight you are getting 2 power 5. Now they are asking what? Smallest integer. See, when you are having negative numbers and positive numbers, obviously the negative maximum will be the minimum number. That means, now tell me, here sign bit should be 1 or 0. For this particular context, whether we have to consider sign bit 1 or 0. All of you confirm? Here they are asking smallest integer. That means sign bit should be 0 or 1. See, sign bit 0 if you consider what? Positive number you are getting. But sign bit 1 you should consider. That's all. Sign bit 1 if you consider, that overall number is what? Negative number. Okay. So here, since you are considering sign bit 1, you have to consider the corresponding position weight as minus. Okay. Now, here our requirement is minimum. That means regarding remaining bits, you can put simply zeros. Okay. Now wherever ones are there, just add the respective position weights. Since we have considered only for sign bit 1, the corresponding position weight is minus 2 power 5. That is nothing but minus 32. That's all. So for representing minus 32, we require 6 bits. Okay. The smallest integer that we can represent in 2's complement form using 6 bits is minus 32. See, it is very simple. Other than this number, you can consider any other number like 1, overall decimal equivalent I am talking, 1, 2, 3, whatever it may be. Minus 32 plus something. That means overall value like minus 32 plus 1, that is minus 31. Minus 32 plus 2, that is minus 30. So among all these numbers, minus 32 is the smallest integer. Right? I hope it is clear for everyone. So for this question, 2 choices are correct. Option C and option D. Option C, option D, both are correct answers for this question. Okay, next question, very interesting one. All of you can give a try. So whatever the series of lectures that you are getting in our YouTube channel regarding our Gate Score Booster session, definitely as the name implies, it is creating enhancement or it is creating improvement in terms of your result. Okay. Say for example, currently whatever the preparation you might have done, with the help of that, whatever the marks currently you are getting. Okay. Definitely let us consider, suppose for EC branch, okay, whatever the total subjects we are having, 10 subjects, for that, based on the possibilities, our faculties, respective subject faculties, we are taking the corresponding session. So all you people, like whoever from EC, accordingly they can watch these sessions based on the possibility in live, and whoever for the time being at that particular live session time, if it is not possible for you to attend live, no problem, you can watch in the later in the whatever the session is available after the live session over, that same lecture will be available in our YouTube channel. Okay, you can watch later also. Similarly for electrical, instrumentation, computer science, even for like mechanical, civil as well. Okay, so whatever the subjects for which we are doing these sessions, definitely after you attend all these sessions and before you attended these sessions, all sessions I mean to say, you yourself can check regarding in terms of your confidence and regarding the kind of knowledge that you have received with the help of this series of lectures. Definitely it is going to create a very good impact in your coming GATE result. Okay, so see, don't hesitate while solving the questions here in this particular live session. Even though some of you are getting wrong answer, don't hesitate. Okay, whatever the answer you are getting, you can mention in the chart, no issue. If you are getting correct answer, I will be definitely appreciating. Similarly, other faculties, whenever you are attending upcoming live sessions as well. And whoever doing the mistake, at least you are rectifying your silly mistakes, so that these silly mistakes you never repeat, or you won't make these kind of silly mistakes in your actual GATE exam. This is the main motto of this kind of series regarding our GATE score booster session. Okay, definitely there will be, like, whoever thoroughly prepared, okay, definitely they might be having overall subject related concepts and method of solving everything, but whatever the minute things where you have to focus and where you should be strong in the basics and fundamentals, each and every corner we are touching in our score booster sessions, so that whatever the learning you are getting from this series of lectures, definitely that is going to help a lot. Okay, but you are doing the mistake now, but if you are not updating your notes, whatever the mistake you have done, and from there what you have learned, if you not update your notes, then you might be doing same mistake even in the GATE exam. But if you want to skip that kind of silly mistakes, and if you want to avoid that kind of silly mistakes, so better keep update, so that definitely you can overcome. Okay, right. Yes, very good Anish, very good. Very good phonics. Yeah, Taran and Medha, you can cross check once. See, in this question, you are having one relation like this. Okay, you are having one equation like this. In this equation, you are having three numbers, 175, 372, 567. Okay, in this particular equation, all these numbers belongs to one particular base or radix, but they haven't mentioned that one. Okay, first of all, let us try to find out that base value. Okay, once if you are getting that base value, you will consider that base value here, and for this number they are asking how many bits are sufficient for representing that number. That is the question. Okay, so for the timing, in order to find the base value x, I am discussing the conventional approach first, and then I will discuss the shortcut. Okay, so conventional approach is simple. Whatever we have discussed, even today's session also, whenever you are having base 5 number, base 6 number, any number system, okay, for that number, in order to find the decimal equivalent, whatever the procedure we have discussed, exactly same. Okay, here all the numbers belongs to base x, and in each number you are having 3 digits. That means corresponding positional weights you will be having x power 0, x power 1, x square. Suppose if you are having only 2 digits, x power 0, x power 1. Since here 3 digits are there, corresponding positional weights, x power 0, x power 1, x square. Okay, now multiply every digit with corresponding positional weight, and then you can add. Okay, so from here you will be getting x square into 1, direct step I am writing, x square plus 7x plus 5. That is related to first number. Okay, similarly related to second number, 3x square plus 7x plus 2 is equal to, okay, here 5x square plus 6x plus 7. 5x square plus 6x plus 7. Now, just do the simplification. 1 plus 3, that is 4. Okay, if you bring to the right hand side, it will become negative. 5 minus 4 is 1. So that means you are getting x square. Okay, then 7 plus 7 is 14. You can bring to the right hand side, it will become negative. So 6 minus 14, that is minus 8. Then here 5 plus 2. 5 plus 2 is 7, and here also 7. That means 7 is getting cancelled. Okay, so or 7 minus 7 is 0, your wish. I hope it is clear for everyone. See, x square terms, and then x terms, and then constant terms, that's all. Okay, now you are getting one equation like this. Now you can take x as common. From here you are getting two roots. Now tell me which root we have to consider for this question. See, in the regular mathematics, when you are solving any quadratic equation, you will be getting two roots. Okay, so those are valid only for that equation. But here x is what? X is the base of the number system. Now tell me whether base of the number system can be negative, whether base of the number system can be 0. Is it possible? It's not possible. Base of the number system should be positive integer. Say for example, if you are having base value 2, you can represent 0 and 1. Okay, so that is the reason here, even though you are getting theoretically like some roots like 0 or negative, because here x is the base, you can eliminate. Since you are having only one root that is positive and non-zero, that root will be the valid base. I hope it is clear for everyone regarding x equal to 8. Okay, now once if you got x equal to 8, now the question is regarding 5, 6, 7 base x. Okay, so 5, 6, 7 base x, x is nothing but here 8. Okay, so here they are asking minimum number of bits that are required. Okay, right. I hope everyone is familiar regarding octal to binary conversion. For every digit we have to represent with 3 bits. Okay, 5 is nothing but 101, 6 is nothing but 110, and then 7 is nothing but 111. See, this whole conversion not required. Only for understanding purpose I have converted octal to binary. Just you have to focus only the leftmost digit. Here 5 is there. For 5, 101 required. Here, like since leftmost bit is 1, definitely we have to consider all these bits here. Okay, similarly here for whatever other 2 digits you are having, individually you require 3 bits each. So in this case, like say for example, if you got suppose here 2 example, then 2 is nothing but what? 0, 1, 0. That leftmost side 0 we can ignore. But here in this case, since you are having leftmost bit 1, we cannot ignore. So here all the bits are compulsory. 3 plus 3 plus 3. That means here we are having 9 ones. Sorry, 9 bits we require. Total we are having 9 bits. So that 9 is there in option C. See here, like option B, option C, here if you observe in this question, option B you are having 8. See, that 8 in this particular solution, that 8 is what? Base of the number system. If they ask for this particular relation, if they ask the valid base, then in that case option B is the correct one. But in this question they are not asking the valid base. Rather they are asking for this particular number how many bits are required in order to represent that number in the binary. Simple. Whenever they are asking bits means in the binary only. Okay, so here 9 bits are required. That is there in option C. So whoever mentioned for this question earlier option B as the correct one, so just cross check whether you have given that answer based on base or based on this logic. If you have given based on this, it's okay, fine for the time being. Okay, but actually in this question they are not asking for base, rather they are asking corresponding bits. So all of you cross check once. Whoever done earlier silly mistake for this question, here actual answer is C, but instead of C, whoever got B as the correct one for this question, all of you cross check. Still, if you are having any doubt, you can mention the chart. If it's clear, you can mention the chart clear so that I will proceed further. Medha, Taran, is it clear? Yes. Okay. Here, for understanding purpose, I have discussed the conventional approach. Okay. In order to find x, you no need to solve this much also. You no need to solve this much also. It is very simple. Without using pen and paper, you can find the x value, provided if you know that visualization for this particular question. Actually, if you remember, in today's session, the first question we have discussed what? Addition of two base 5 numbers, right? There, number system base has given, but here number system base is not given. That is the only twist, that's all. But in that question, we are performing addition. Even in this question, left hand side, if you observe, you are supposed to perform addition operation only. Okay, even though here context is to find the base, but left hand side equation, if you observe, you are adding two numbers. Okay, right, that's all. So just I am considering what are the two numbers you are having, 175 and then 372. Here for these two numbers, we have to perform the addition operation. Definitely you will be performing addition from the rightmost digit and then go towards left hand side digit by digit, right? Now, here it is very simple. After you are performing addition like this, okay, digit by digit you have to check whatever the resultant digit here you are getting and here digit. Okay, if the digit value is same, that time no need to do any adjustment. But if the digit values are not same, then we have to do some adjustment. With the help of that logic, you can easily get the base of the number system. Okay, right. So here 5 plus 2 is 7. 5 plus 2 is 7. Yes, here also 7 is there. So since here 7, it is matching. No need of any adjustment. Okay, right. Next, 7 plus 7. 7 plus 7. Here while you are performing the addition, you are treating like decimal. Okay, right. So 7 plus 7, you are getting what? 14. 14 in the decimal number system, obviously we require two digits. Okay, now just see here, you are having what? 6. Actually, after performing addition of two numbers like 7 and 7, you are getting 14. But here the second digit what they have given? 6. That is the hint point. Now in this question, like simple logic. Here first number you are having 3 digits, second number you are having 3 digits. Okay, after performing addition of two numbers like this, at most you can get 4 digits. But here in this question they have given 3 digits only. That means after performing addition of these 2 digits, it has to match with this one. After performing addition of these 2 digits, it has to match with this one. After performing the addition of these digits, it has to match with this one. That's all. Now first iteration it has matched, but second iteration mismatch happened. When mismatch happened, very simple, that iteration or at that context, we cannot represent the resultant sum with the help of single digit. Obviously we require one more additional digit, that is nothing but carry. That's all. That means whatever the digit they have given, that digit is nothing but some digit. Okay, now tell me, by adding with which number you are getting resultant value as 14? By adding with which number you are getting resultant value as 14? That itself is the base. That's all. Here by adding with 8, you are getting 14. That means, say for example, if you are having 16 base 8, right? Here positional weights are what? 8 power 0, 8 power 1. So 8 into 1, that is 8, plus 1 into 6 is 6. That's all. This 6 is nothing but some digit and 1 is nothing but carry. That's all. So now it is matching. Yes or no? Here 6 is the sum digit, 1 is the carry. If carry comes, carry we will be adding at the next higher digit. That's all. Okay. In this manner, suppose example in the starting iteration only if there is a mismatch, definitely with the help of that one iteration you are getting the final answer. But whenever the starting digit is matching, then you have to go for the next digit. Wherever like that you have to continue till the leftmost, but in this process at whichever stage you are getting mismatch, with the help of that one you can easily find the corresponding base. That's all. No need to use pen and paper. That much dead easy question. Okay, right. Now 1 plus 3 is 4, 4 plus 1 is 5. Yes, exactly matching. Whenever exactly matching, no need of any adjustment. That's all. Okay, we have just continued whether the final answer is matching here or not. That's all. Okay, right. So this is the final answer 5, 6, 7. That is happening in the base 8 number system. See, this is one approach. Suppose, sir, I am not comfortable. Whatever the shortcut here you have discussed, no issue at all. No issue at all. Whatever the 14 here you got, that 14 is nothing but what? Decimal number. That 14 decimal number convert into octal. That's all. By performing repeated division, there also you are getting 8 ones are 8, remainder is 6, 8 zeros are 0, remainder is 1. That's all. 1 6 only. There also you are performing like decimal to octal conversion. So from there also you are getting 1 and 6. Okay, right. But here like just for like when you know the base, that time you are able to, but here you don't know. That's why we are performing. So simple logic here, one digit is not sufficient, one more additional digit required. That digit always will place 1 only, but equivalent value of the carry is nothing but base of the number system. Here in this case, hint point is this sum digit is there. By adding with whichever number you are getting, that is nothing but base. That's all. I hope it is clear for everyone. Here x is nothing but 8. Once if you got base value 8, after that here also for understanding purpose we have converted into binary. This much not required. Anyway, for 7 3 bits required, for 6 3 bits are required, for 5 when you represent 3 bits 101 you are getting, because leftmost digit is 1, definitely all the 3 bits required. 3 plus 3 plus 3, that means 9 bits. That's all. Okay. In this way, for whichever questions, not only in this subject, even other subjects, whichever questions you can easily solve without using pen and paper, try to solve in that approach. Definitely because of that you can score more marks in the GATE exam. Okay, right. Yeah, next question, all of you give it a try. I hope all of you can get the correct answer for this question. Yes, very good Anish, very good Phoenix. Yes, very good. So here in this particular question you are having one relation like this. Okay, in order to hold this particular relation, how many possible solutions we are having regarding x and y? That is a question. So here left hand side base value is known, that is 8. Now the corresponding position weights you can put in powers of 8, that is 8 power 0, 8 power 1. Next, here right hand side base value we don't know, but base y is given. Base they have represented as y, so in powers of y you can represent, that's all. Y power 0, y power 1. Now represent the equivalent expression, equivalent value. 8 into 4, that is 32, plus 8 power 0 is 1 into 3. Then y into x, or xy, your wish. In any order you can write. Then y power 0 is 1, 1 into 0 is 0. From here you are getting one simple equation that xy equal to 35. Earlier you got one quadratic equation, for that we found the roots. Okay, but here you are getting one simple equation like xy equal to 35. Okay, so it is very simple, like you have to consider two numbers in such a way that after multiplying those two you should get 35, that's all. Okay, like that you can write, or in other words, for 35 whatever the factors you are having you can consider, that's all. Okay, say for example, here I am assuming x value first, accordingly I am considering the corresponding y values. X value 1 if you consider, y value will be 35. Now x value 2, suppose if you consider, what will be y value? 35 by 2, how much you are getting? 17.5. Whether we have to consider or not, whether we can consider or not. When you consider x value 2, y value you are getting 17.5. Whether we can consider or not. All of you confirm? See, with respect to normal mathematics we can consider, but here with respect to our digital circuit subject regarding number system conversions, with respect to that logic, here y is what? Base of the number system. Base of the number system, we already mentioned the conclusion point, it should be positive integer other than 0, right? It should be integer. It should not be fractional number. It should not be real number as well, right? So that means we should not consider 2. Then go for 3, not possible. Go for 4, not possible. Then go for 5. 5 7s are 35. Now after this, if you continue, 6 not possible. Then 7 5s are 35. Then 35 1s are 35. Okay. So from the tabular form, you are getting, like, in order to get the 35 after multiplying two numbers, you are having, like with repetition you can say, okay, 135, that is one combination, 5 and 7, 7 and 5, 35 and 1. From the tabular form you are getting 4 possible solutions. Okay, because of that some students may answer for this question 4, but that may be correct or may not be correct. Okay, how to decide? Very simple, like just observe here. Here y is what? Base of the number system. Here y is the base of the number system. So now just whatever the y column numbers you got, just consider in place of y, that's all. So in place of y, when you consider 35, base of the number system 35 possible, there is no doubt. Okay, here one digit is 0, yes we can represent. Another digit x value we got 1, yes we can represent. In base 35 we can represent 0 and 1, no problem. So this is the valid. Okay, next, this is the valid one. Next, you can consider this combination. Base 7, x is 5, yes we can represent. In base 7 number system you can represent 0 and 5, yes. Now tell me, when you consider this combination, base value is 5 but x value is 7, is it possible to represent in base 5 number system the digit value 7? Is it possible? Similarly, when you consider base of the number system is 1, is it possible to represent the digit value as 35? Not possible. That is the reason these two are not the valid. Even though theoretically you are getting the solutions, but according to our base or radix concept, okay, according to that concept, in base 5 number system we cannot represent digit value 7. In base 5 number system maximally we can represent 4 only. Like that you can just consider whatever the base values here you got, consider that base value here and the corresponding x value. In that manner you can just verify whether you can represent whatever the digits here you are having, whether all the digits you can represent in that number system or not. If you can represent, then definitely that is the valid solution. Otherwise, whichever combinations are not satisfying with respect to our base concept or radix concept, that combinations you can avoid, that's all. So only 2 solutions for this question, answer will be 2. Okay, I hope it is clear for everyone. Yeah, next question, all of you give a try. Yes, very good Anish, very good Medha, yes, very good. See, in this question you are having two numbers, both the numbers represented in hexadecimal. You have to perform the hexadecimal addition, and here they are asking the gray code. Gray code we can convert from binary to gray, right? So that means whatever the resultant hexadecimal number you got, convert into binary. For that binary you can convert into the gray code. Okay. So here once again with the help of this question you are getting once again recap or revision regarding the addition operation in other number system. Okay, already we have touched earlier like base 5 and other number system also, and here you are getting hexadecimal addition. So whatever the numbers here you are having AB base 16 and then CD base 16. Now here B is nothing but 11, okay, D is nothing but 13, okay, just for reference I am mentioning. B is nothing but 11, then D is nothing but 13. So 11 plus 13, that is nothing but 24. So 24 we cannot represent with a single digit in hexadecimal. So that means you require one more additional digit, that is nothing but carry. So this 24 how we can write? Because here base of the number system is 16, so you can write 16 plus something. Here that something is nothing but 8. So that means you are getting two digits, 1 and 8 belongs to base 16. Here 8 is the sum digit and 1 is the carry. Is it clear for everyone up to this point? Regarding addition of these two digits, how I represented 1, 8, is it clear or not? All of you confirm in the chart. Medha, Anish, is it clear how to represent after addition of these two digits the resultant answer as 1, 8? Is it clear or not? Yes, clear, very good. So this is one method, and one more method, just I am giving a hint, like whatever the 24 you got, that is a decimal number. If you want to convert into hexadecimal, you are performing repeated division operation. 16 ones are 16, remainder is 8. 16 zeros are 0, remainder is 1. That means 1 and 8, these digits belongs to hexadecimal, that's all. Okay, one approach you can do from number system conversion, another approach you can do from the addition operation with respect to any number system. Okay, whenever it exceeds the maximum capacity of that digit in that number system, so definitely you require additional digit, that is nothing but carry. Equivalent value of carry is nothing but base of the number system, base plus something, that's all. Now here like C value is 12, 12 plus 1 is 13, 13 plus 10, that is 23. So just for reference I am writing A value is 10, then C value is 12 and then 1. So 12 plus 1, 13, 13 plus 10, 23. You are getting 23, this is the decimal number. Okay, this one we can write it as 16 plus 7, that means here also we require two digits belongs to hexadecimal, 1, 7. So here 7 is the sum, 1 is the carry, that's all. After performing the addition of these two numbers, the resultant hexadecimal number is 178. See, that is also there in one of the choice. Okay, sometimes few students won't read the question completely. They might assume that they are just asking that addition of these two numbers. Okay, once if they consider that much, then that answer is there here in option A. But here they are asking the corresponding gray code. Okay, so that means whatever the hexadecimal number here you got, convert into binary first by representing every hexadecimal digit with 4 bits. Okay, so here 178 base 16, 1 we can write it as 0001, then 7 we can write it as 0111, then 8 we can write it as 1000. This is the corresponding binary number. Okay, now this binary, in order to convert into gray code, either binary to gray or gray to binary, the first step is same. Whatever the leftmost bit we are having, whatever the leftmost bit we are having, copy as it is. So here that is 0. After that, among successive bits you can perform XOR operation, that's all. 0 XOR 0, 0. Next 0 XOR 0, 0. 0 XOR 1, 1. Then 1 XOR 0, 1. 0 XOR 1, 1. 1 XOR 1, 0. 1 XOR 1, 0. 1 XOR 1, 0. Then 1 XOR 0, 1. Then 0 XOR 0, 0. Then once again 0 XOR 0 is 0. Okay, right. Whatever here we got, that is a binary code. Just for reference, here I am putting like suffix 2. Whatever currently we got, this is the grey code. This is the grey code. But here in this question, they are not given the choices in terms of zeros and ones. Rather, whatever the grey code currently you got, once again, if you do the grouping of 4 bits, you will be getting hexadecimal digits. That representation they have given. So here 0 1 0 0, that is nothing but 4. Okay. Then 1 1 0 0 is nothing but C. Then 0 0 0 1 is nothing but 1. So 1C4 base 16. 1C4 base 16, that is there in option C. Option C is the correct answer. Yes, for this question everyone got correct answer. I am appreciating all the students. Okay. Yeah. Up to now, whatever the questions we have discussed so far in this particular session, all the questions related to the first chapter, that is number systems and codes. Okay. Now we are going to discuss the questions related to the second chapter, that is Boolean algebra and K-maps. All of you give it a try. So here in this question, they have given one expression like A XOR B XOR AB. That overall expression you have to do the simplification, and after that among 4 choices with whichever option it is matching, that will be the correct one. So one approach for this question, you can give it a try later, like say for example A XOR B expression, you know, like A bar B plus AB bar. Like that, whatever the expression you got, that one you can consider like X. Another variable like Y. Here that Y is nothing but AB. Once again the same formula, X exclusive Y is nothing but X bar Y plus XY bar, where X is nothing but A XOR B expression after expanding whatever you got. Similarly Y is nothing but AB. So that expression you can do the simplification. After that you will be getting the whatever the here 4 choices are available, definitely it will match with one of the choice, but that will take more time. Okay, but you people can give it a try later. That method I am giving as a homework. Okay, but for the timing I will discuss in another method. With the help of that method you can get the answer quickly. Yes, very good Taran, phonics, very good. Option C is the correct one, very good. So for this question it is very simple. Here when you observe the overall expression, it is a function of 2 variables A and B. Okay, So first of all, I am considering two inputs A and B. When you're having two inputs, we can represent four combinations of zeros and ones. 0 0 0 1 1 0 1 1, right? Okay. Now whatever the expression here you're having, here entire expression you're having exclusive OR operator, and we know that XOR operator satisfy associative law, right? So first you can perform A XOR B, and then you can perform XOR with AB. Okay. So here I am considering A XOR B, right? And then here the last term you are having AB. After that, among these two we have to perform XOR, that is here you are getting. Okay, right. So regarding A XOR B, regarding AB, I hope everyone familiar regarding the truth tables, right? Okay. So A XOR B means you are getting 0 1 1 0. A and B you are getting 0 0 0 1. When A and B are equal to 1, that time you are getting 1. Whereas for A XOR B, 0 1 combination, 1 0 combination, you are getting 1. Now among these two columns you have to perform, for every row you have to perform XOR, that's all. 0 XOR 0, 0, next 1 XOR 0, 1, 1 XOR 0, 1, 0 XOR 1, 1. Now after you are getting like this, forget about these two columns, just compare with respect to your inputs and the output column, that's all. For which logic gate you will be getting the output column like this when you are having two inputs A and B like this. It is very simple. Just observe, when all the inputs are 0, that time you are getting 0. If at least one input is 1, that time you are getting output as 1. That is nothing but OR gate. Yes or no? That is nothing but OR gate. So whatever the expression here they have given, so A XOR B XOR AB. So this entire expression is same as whatever, whatever the expression they have given, I have modified like this: A XOR B XOR AB, because XOR operator satisfy associative law. Okay. Now from here conclusion point we got this nothing but A plus B. A plus B. That is your OR gate. A plus B, that is there in option C. So all of you confirm, especially the students whoever couldn't able to attempt this question, or whoever got the wrong choice as the correct one, those students can confirm whether it is clear now or not. Yes, I hope it is clear for everyone. Right. Next question, this is a very important question for CS branch. This is very important regarding self-dual concept. See, I hope you might be having the idea regarding the self-dual. So first of all, duality means what? Whenever you are having one logic function, okay, in that logic function, among the variables, you might be having, among two variables I am talking. Okay, whenever you are having two variables, among which you can have either logical AND or logical OR. Of course, you can have various other operations also, but among all the operations, the basic binary operations are logical AND logical OR. So these two operators we have to interchange, and if zeros and ones are present in the given expression, we can interchange. Then whatever the function currently we are getting after applying these two conditions, that function is dual of original. Okay. So in majority of the cases, the original function and the dual function both are not same. Say for example, if you are having the like A and B, suppose you are having A and B is there, what is the dual of that one? For A and B, you are having one logic function A and B, what is the dual? A plus B, yes or no? Whether A and B, A plus B, whether both are same or different? Both are different. So in this way, whatever after applying dual, the original function and dual function, in majority of the cases those are different. But in few cases like original function and dual function both will be same. If that is so, then that function itself is a dual. That particular function we are calling it as self-dual. Okay, say for example, now all of you give a try. Just very simple question. What is a dual of A? What is a dual of A? You are having one function A. What is the dual of it? Is it A or is it A bar? Yeah, some of you might be saying A bar, but actually it is not A bar. Just now only I have told, when you are applying dual, we are not changing the variable. We are keeping the variable as it is. If it is A, as it is. If it is A bar, as it is only. Okay, we are not changing the normal form into complement or complement form into normal. We are not changing the variable. Only we are interchanging the corresponding basic binary operators. So that means, say for example, here just example I am writing, like A we are having, after applying dual, here in order to apply dual, if you are having two variables, then we can apply. The reason is simple. When you are having AB, among which you can have logical and or logical or, that operator we can interchange. But here there is no second variable, that means dual same only. Similarly, if you are having A bar, dual is same only, A bar. Or if you are having any doubt, it is very simple. I am giving one more approach also, no issue. Like A into 1. See, whatever A is there, I have written as A into 1. Now, by applying dual, what you are getting? A we are keeping as it is. Here logical and we can replace as logical. Here constant 1 replace as 0. So A plus 0 is what? A. So original function is A. After applying dual also same A. Okay. Similarly, the same concept here also you can apply. A bar into 1. After applying dual, A bar plus 0, that is A bar. Vice versa. So in this case, like just for understanding purpose, I have considered simple example. When you are having, like after doing the simplification, if you got the simplified function as A, after applying dual, you are getting same function. Similarly, after simplifying the given function, if you are getting A bar, after applying dual, same function, that is A bar. In this case, the original function and the corresponding dual function both are same. Those are the examples of self-dual. I hope it is clear for everyone regarding self-dual. It is very simple. The dual function and original function both are same. That is the reason the function itself is a dual. That's all. The function itself is a dual. Okay, right. Now, for this question, you are having 4 choices. Okay. So here, like when you are getting like this kind of questions in the GATE exam, whatever the approach I have told, like you are interchanging the logical and logical and ones and zeros, if you are interchanging, definitely this is the MSQ question, right? It may take more time. It may take more time in order to identify. So see, when they are asking that, they are giving one function, and if they are asking you to find out the dual, definitely what is the logic we have told, you will be applying, no doubt about it. But even that logic, when you are applying also, suppose as I mentioned earlier, even though majority of the cases, the original function, dual function both are different, but in few cases you are getting the same. That is the reason. Even if they are asking you to find out the dual of one function, before blindly following the conventional approach, whatever the 2 conditions currently I am going to discuss, if those 2 conditions satisfy, the original function and dual function both are same. No need to apply regular conventional approach for dual. Suppose if the 2 conditions not satisfy, then definitely you have to follow your conventional approach in order to find the corresponding dual. Okay, right. I hope it is clear for everyone what is dual and what is self-dual. Okay, now I am asking one simple question, like with respect to mathematics, like when you are tossing a coin, either head will come or tail will come. So at any point of time, whether both can happen at the same time, is it possible? At any point of time, whether head and tail can occur at the same time? No. That means these 2 combinations, we can say it is a mutually exclusive, right? If head occur at the same time, tail won't occur, or if tail occur at the same time, head won't occur, right? So in the similar way, whenever you are considering, suppose for single variable I am talking, when you are considering a value 0, at the same time, is it possible to consider 1? No. Similarly, if you are considering a value 1, at the same time, it is not possible to consider 0. That means these are mutually exclusive. Simple. So in that manner, so it is very simple. Like here the question is function of 3 variables. When you are having 3 variables, total you can get at max or at most 8 minterms. 8 minterms you can get. Now the first and foremost condition, whenever you are saying the given function as self-dual, the first and foremost condition, it should satisfy that in the given function, with respect to the given variables, whatever the total number of minterms you are having, out of which half of that. That means total number of minterms you are getting 8, half of that, that means 4 minterms. That is the first condition. Okay. Then second condition is there should not be any mutually exclusive minterm. Okay. So why we are discussing the first condition, you will be getting the clarity with the help of this tabular form. Okay. So just observe, when you are having 3 bits, total you will be having 8 combinations in terms of zeros and ones, among which first I have written like 4 combinations like 000, 001, 010, 011. Now whatever the combination here you have considered, just take exactly complement, one's complement. 000 complement is 111, 001, 110, 010, 101, 011, 100. Okay. So say for example, if 000 combination occur, at the same time in that function 111 combination should not occur. Okay, simple logic. Or with respect to exam point of view, how to consider this condition? Okay, without writing this much, it is very simple. Whatever the combinations here we have considered, just convert into decimal equivalent. Okay. Now you write the numbers in the pair form in such a way that when you are having 3 bits, the maximum decimal equivalent you can represent as 7, because 111 is nothing but 7. Now in order to get the 7, you can consider the 2 numbers in such a way that after performing addition, you should get 7. That's all. 0 plus 7 is 7, 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7. That's all. Okay. So here, like this entire combinations I have discussed just for understanding point of view, but exam point of view, no need to write this much. Okay, whenever you are supposed to decide whether it is self-dual or not. Simple. I already given the hint point. With the help of that hint point, write the 2 numbers in this manner. Now here it is very simple. After you have written like this, like from each set, only 1 minterm we should consider. That's all. Say for example, among these 2, any 1 minterm, among these 2, any 1, among these 2, any 1, among these 2, any 1. That's all. So like that, when you considered one, total you are getting what? 4 minterms. That is nothing but from the total minterms, whatever the total number you are having, among that half. That's all. That is the reason first condition. Okay, right. Now when you are having the choices like this, you understood that for 3 variables 8 minterms are there. Now in whichever choice you are having, half of that total number, that is 4 minterms. Okay, like that here A, B you are having. So that means the moment first condition satisfy, now you just verify the second condition whether it is satisfying or not. If the second condition satisfy, then that function will be the self-dual. That's all. Just observe here, like first I am observing option B, like 0 is there, from the first pair only 1 0. Okay, next second pair 1 and 6 is there, third one 2 and 5 is there, and 3 and 4 3 is there. That means from each pair only 1 minterm. That means B is a self-dual. Similarly you can observe here, like 0 and 7 is there, then among 1 and 6 1 is there, 2 and 5 2 is there, 3 and 4 is there. Okay, like that from each pair only 1 minterm should be there. Suppose example, in one of the choice they have given like M3 plus M4. That means it is not the self-dual. For that function, if they ask you to find the dual, definitely you have to apply the conventional approach only. Okay, I hope it is clear for everyone. Is it clear for everyone regarding this question? This question is very important for CS branch regarding self-dual concept. So for this question, 2 choices are correct, A and B. Yes, very good, Taran, very good. You are from which branch, Taran? Yes, all of you give a try for the next question. This is the MSQ. This question is MSQ. All of you give a try. Yeah, easy. Okay. In this question, they have you are having one Boolean function. For this Boolean function, among the 4 choices, whichever are equivalent, choose the correct option or options regarding the Boolean function. It is an MSQ question. 2 choices you are having sigma m form. 2 choices are there in pi capital. Yeah. So whatever the given function is there, so based on your convenience, if you want, you can solve this question by using K-map also. Okay. But here the question is not regarding the simplification. Rather, you should get the standard function or original function. Okay. Right. Yes. Very good, Anish. Very good. For the time being, I am discussing one more approach. Okay. So whatever the given function is there, first just verify whether you can do the simplification or not. Okay. So that you are getting completely in the minimized function. From there, we can get our standard function. Okay, right. So first of all, if you observe, like from the first term and third term and fourth term, I am taking A as common. From first, third and fourth, I am taking A as common. So A into 1 plus B d bar plus B c d. Okay, after that the second term I am writing. Second term I am writing. Okay, right. Now just tell me here this entire value, it can be 0 or it can be 1, no matter. Okay, 1 plus anything. Here plus operator indicates what? Plus symbol indicates logical OR. Okay, 1 plus anything is what? 1 only, logical OR. That means here this entire value is 1. Now A into 1, that is nothing but A plus BC bar. Now whatever the original function you are having, after doing the simplification you got A plus BC bar. Now this function is what? SOP form. This function is SOP form. In the GATE exam regarding this particular chapter, you will be getting 2 variety of questions. Okay, based on either they can ask like the original function is like sigma m or pi capital M, they can ask the simplified form SOP or POS. That is one approach, one variety of the question. Or another variety you may get like they will give the simplified form either SOP or POS. With the help of that they can ask the equivalent sigma m or pi capital M. Okay, right. Now for the time being, whatever the original function you are having, okay, that function I have done the simplification, I got SOP. Okay, now from SOP we can get the sigma m. So here first of all write the variables order as it is, ABCD. Okay, Now consider the first term. Here the first term is what? A. So that means while you are writing the min terms or product terms, the convention is same. If you are having A, that means A value is 1. Regarding BCD, 3 bits are unknown. That means with the help of 3 bits, you can write 8 combinations like 000 to 111 regarding BCD. But among all those combinations, A value should be 1 only. That means the corresponding min terms, since you are having leftmost bit is 1, corresponding position bit is how much? 8. 8 plus 0, that is 8, and maximum value is 8 plus 7, that is 15. So that means you are getting min terms 8 to 15. I hope it is clear for everyone. M8 to M15 you are getting. The moment you are getting like this, now just observe the choice. Here 8 to 15, yes, it is matching because of this one. Yes, 8, 9, 10, 11, 12, 13, 14, 15. All the min terms are there. Okay, right. Now let us consider B into C bar. So here in this case, B value is 1, C value is 0. B value is 1, C value is 0. Here A and D are missing. A and D are missing. Since 2 combinations are missing, you can write according to the corresponding 4 combinations of zeros and ones. But for all the 4 combinations, BC value remain at 1, 0. Okay. Here I am considering regarding A and D, you can consider like 0, 0 or 0, 1 or 1, 0, 1, 1. These are the 4 possible combinations. Okay, now write the corresponding min terms. You are getting M4, then M5, then here 12, then here 13. So 12 and 13, see whatever the overall min terms you are getting, after that we will perform logical OR only, sum of min terms, right? So M12 plus M12 is M12 only, just like x plus x is x. Similarly, M13 plus M13, that is M13 only. So whichever terms are repeating, you can consider one time. Okay, because this one already repeated here, this one also repeated here. So whatever the unique terms you are having, so those unique terms you can consider, that's all. So 8 to 15 we already discussed here. Now in addition to that, you should get 4 and 5. Yes, exactly here also we are getting 4 and 5. 4 and 5 we are getting. Okay, so that means since option C matched, now it is very simple. Whatever the numbers here you are having, okay, for these combination of inputs, output you are getting 1. That means for remaining combination of inputs you are getting output as 0. That's all. Now when you are having 4 bits, the corresponding decimal equivalent 0 to 15. 0 to 15, in that range, other than these numbers, remaining numbers are producing output 0. That's all. So 0, 1, 2, 3. Okay, 0, 1, 2, 3. Then 4, 5 present here. Then 6, 7. After that, 8 to 15, all the terms are present, right? So that means for this question, C and D, both options C and D are correct answers. Okay, I hope it is clear for everyone. Yeah, next question, all of you give a try. So in this question you are having the Boolean function f of a b c, that is a plus b bar c. For that, this question is MSQ. Okay, in option you are having 5 min terms, option B you are having 3 max terms, option C PYS form they have given, and option D number of literals present in the minimized function as 3. Okay, you have to verify whether all these options are correct or some of the options are correct. Okay, whichever options are correct you can mention in the chart. So just now only we have discussed the shortcut procedure like SOP to sigma m. Okay, just now only we have discussed. Once again you can follow the similar approach, but only the difference here we got a plus bc bar, but here you are having the expression a plus b bar c. Okay, that is one thing. And one more thing here, the given function is function of 4 variables, but here in this question it is a function of 3 variables only. Okay. Yeah. Okay, I will discuss. So just like earlier, first of all write the variables order as it is. Okay, here the first term you are having a, that means a value is 1. Regarding bc, 2 bits are there, you will be getting 4 combinations, right? So now you can consider like 0 0 0 1 1 0 1 1, but leftmost bit is 1, that means corresponding min terms you are getting 4 5 6 7. 4 5 6 7. Okay, right. Next, second term I am considering b bar c. So in this case b value is 0, c value is 1. Regarding a, 2 combinations, it can be 0, it can be 1. If you consider 0, you are getting m1. If you consider 1, 1 0 1 is 5. So m5 already repeated, you can consider 1 time. Okay, what are the min terms here you are getting? We have to sum together, that's all. So here just count the min terms, you are getting 1 2 3 4 5, that means you are getting 5 min terms. So from here you are getting number of min terms are 5, and since the question is function of 3 variables, if it is a function of 3 variables, totally you are getting 8 combinations. Okay, out of 8 combinations, 5 combinations are producing output 1, that means remaining 3 combinations are producing 0, that's all. Okay, so here 5 min terms we got, so that means from here it is self understandable that we are getting max terms are 3. So as of now, option A, option B, both are correct. Okay, yes, very good Medha, very good. As of now 2 choices are correct. With respect to this one, option A is correct. With respect to this one, option B is correct. Now let us see regarding option C. Option C is PYS form. Okay, the given function is SOP, the equivalent PYS they have asked. Okay, see here in this particular question, like you are having a plus b bar c, this is the function we are having. So this function, for this particular equation I am talking, for this particular equation, by using distributive law we can get PYS form. By using distributive law we can get PYS. Okay, just like when you are having x plus yz, you can write x plus y into x plus z. Okay, so here you are getting a plus b bar, logical and a plus c. Yes, a plus b bar into a plus c. Yes, that means option C is the correct one. Option C is also correct. Okay, yeah, no issue Phoenix, no issue. So as of now we are getting 3 choices are correct. Now option D also we have to decide. That is the beauty of MSQ. See, the moment if the question is MCQ, whether really you know the 3 choice among the given 4 choices, whether really you know out of 4 choices whether 3 choices are wrong or not. Irrespective of that, the moment you are getting correct option, you no need to verify remaining choices. But whereas for MSQ, you have to verify each and every option whether it is really correct or not. Because in the GATE exam, for MSQ question, there is no partial marking, there is no negative marking also. Say for example, for this question, if all the 4 choices are correct, suppose you have mentioned only 3 choices like ABC or ACD or BCD, suppose, you won't get partial marking. Whichever correct options are there, if you select all those correct options, then only you will get the marks for that question. Okay. Now, option D is regarding the number of literals present in the minimized function. Okay. So this is SOP form, this is POS form. Okay. Literal means very simple. See, in general, when you are having a function, we are representing in terms of variables. Okay. Here variables are what? A, B, C. Okay. Coming to this function, here A is the normal, C is the normal, but B is in the complement version, right? So the variable either in its normal form or in its complement form, that one we are calling it as literal. Okay. So you can observe this function or this function. Here one literal, okay. Yes. So here 1, 2, 3. 3 literals are there, or even you can observe here both are same only, that means you can count one time. Okay. Then second, third. So either with the help of this function or this function, both are minimized only. This is a sum of products, this is a product of sum. Okay. In both the minimized functions, you are having number of literals individually 3 only. That means option D is also correct. Okay, for this question, all the 4 choices are correct. Okay, if any of you are having still any doubt regarding any choice, sir, how that option is also correct. If you are having any confusion or doubt, you can mention the chart. Okay, I hope it is clear for everyone. Next question, this is a very, very interesting question. I can say it is an excellent question. All of you give it a try. For this question, if you are able to get correct answer, that means definitely you can solve the question regarding Boolean algebra concept. No matter the level of the question they can give, whatever may the toughness, no matter, you will be getting correct answer in the GATE exam. So this is the deciding question. Okay, all of you can give a try. All of you can give a try. If you want, I will be giving, I can extend the time also later, but initially I am giving 3 minutes time. All of you put your 100% effort. If you are able to get in this limited time, it is fantastic, but even if you want some extra time, I will be giving. No hurry at all, but put your 100% effort. Try to get the correct answer. This is a very, very interesting question, excellent question. I am giving 5-star rating for this question. So why I have given 5-star rating for this question, you will come to know after solving this question and after you are getting correct answer. Okay, till then I am keeping a suspense. Why I have given 5-star rating for this question, and after I discuss the solution, whoever like or whoever agreeing that sir this is an excellent question and 5-star rating question, and you people can mention the chart section as well, and whoever watching this particular session later, those students can mention in the comment section. So you just mention the question number, and you, if you are agreeing for excellent question, you can write, or otherwise regarding stars. Okay, 5-star. From my side I have given 5-star, but whatever the number of stars you want to give, accordingly you can give after solving this question. Okay. So whatever the questions currently I am discussing regarding digital circuit subject, okay. Similarly, I will be coming for gate score booster session in the live in our YouTube channel for 2 more subjects like network theory and then communication as well. Like this weekend, Saturday, Sunday, I am discussing gate score booster regarding digital circuit subject. Similarly, upcoming weekend, Saturday, Sunday, regarding network theory subject. After that, 1 more week, communication subject. Okay. So for EC branch, you people are lucky, you are able to attend my sessions for 3 subjects. Okay. And each subject I am discussing in 2 sessions. Okay. Whereas for electrical students, at least for 2 subjects, like digital circuits and network theory, whereas for computer science only digital. Okay, right, no issue. Whatever the sessions you are attending regarding my subject, whatever the questions I am discussing here in the live, all those questions are not at all gate questions. But whatever the questions here we are discussing, definitely those questions are expected models or variety of questions for your coming gate exam. Okay, all of you can assess your confidence level in terms of attempting the questions and in terms of knowledge also. Okay, like what, at least say for example before attending the session whatever might be the level you might be having, but at least by the end of second session of every subject, whichever you are attending, my subjects especially, okay, after attending the second session, at the end of second session you can decide whether you got the enough confidence or not. Say for example, very simple straightforward question, whichever subjects you are attending like digital, network theory and communication, right after the second session immediately if your gate exam is there, regarding that subject, whether you are in a position to go and attempt the questions or not regarding that particular subject, if you are able to get the answer with with strong mindset, that is very fantastic, because that much is more than sufficient, because after that you don't need to practice anything. But whatever the limited days you are having still in front of, before your gate exam, you can do more practice or revision based on the possibility. Okay, right. Yeah, Anish, whatever the number you mentioned, those are like number of sum terms you are mentioning. Okay, just cross check Anish once. Okay, whoever want more time for this question, just mention the chart so that I will be giving time extra. But whoever want me to discuss now, according you can mention the chart, I will I will discuss also. Whether you want me to wait or whether I have to discuss, you can mention the chart. Anish, you can cross check once. Actually in the question they are asking what? In the PYS form. PYS form means simplified function, right? Product of sums, that is in the simplified form. In that simplified form, they are asking how many sum terms are there. There is a difference between product of max terms and PYS form. Product of max means what? Like here you will be having like this. Say for example pi capital M. When you are having that one, that is a product of max terms. But like say for example for this question, after doing the simplification, just like this question, after doing the simplification you got like this. Here these are the sum terms. Okay, the difference between sum term and max term is very simple. In the sum term you are performing logical OR. In the max term also you are performing logical OR among the variables. But the condition is what? Whatever the number of variables given, and in that sum term or logical OR term, if the number of literals and the number of given variables both are matching, then the respective sum term or logical term we are calling as max term. Otherwise simply we are calling as sum term. That's all. Yes, very good Medha, excellent. Even though you have done silly mistakes earlier, but at least now you got correct answer. Okay, at least be on track from now onwards. Okay, right. So which laws you have applied in order to do the simplification of this function? Whoever tried this question till now, all of you mention which laws you have used. Just mention the name of laws of Boolean algebra that you have used in the chart. Whoever attending this session later, they can mention in the comment section as well. At least you can mention whichever main laws that you have used in order to answer this question. At least mention the name of laws, so that I will come to know that whether you, whatever the answers you got, whether it is really it is matching or not. I want to confirm whether your approach is correct or not. Sometimes few students may guess. That is the reason I want to cross check for this question, because I have mentioned excellent question and 5-star rating here. Yeah, okay. Meanwhile, you can mention the chart. So here this is a very, very interesting question. So now just observe, whatever the function here you're having on the right hand side, for overall function you're having complement. Yes, very good, Medha. Yeah, first step, directly you apply De Morgan's. Okay. Actually, the moment you are having complement overall function, majority of the students will apply directly De Morgan's law. But before applying De Morgan's law, of course you may get correct answer, but after taking so much iteration or after taking so much time. But if you want to get the answer quickly, before applying De Morgan's law, first cross verify whatever the function they have given under the complement, whether we can do simplification or not. If it is possible, first do it, so that after that simplified expression, whatever you are getting, after that if required, you can apply De Morgan's law. Okay. Even originally also you can apply De Morgan's law, but it may take more iterations or it may take more time. Okay, right. Yes, very good, Tarun, very good. So for this question, whatever the right hand side function you are having, before applying De Morgan's law, we can do the simplification. If you carefully observe, then only it is possible. Initially you may thought that, sir, we cannot simplify this function, but if you closely observe, we can do. So for this question, you can observe here, I am talking only under the complement 3 terms are there, just observe those 3 terms. Here P is present, here Q is present. In this particular term, what is the missing variable? When you observe this entire function, it is a function of 3 variables, P, Q, R. Among that P and Q present, P is present here, Q is present here. Here R is missing, so that R normal form present here and the corresponding complement form is present here. Yes, both the conditions satisfied. This is regarding consensus law. When these 2 conditions satisfy, then we can bring 3 terms into 2 terms. Medha, just confirm, have you applied consensus law or not before applying De Morgan's law? QR bar plus PR. This is a simplified function you are getting. Now you keep as it is regarding the complement. Now this is a simplified function we got. We cannot do further simplification. Now you can apply De Morgan's law. Okay. First term complement, then here logical, then second term complement, and then keep action. Sorry, it is like x plus y whole bar. That means x bar into y bar. Okay. So here the first term I am writing Q into R bar. Second term I am writing P into R. Now once again individually you can apply De Morgan's law. So here you are getting Q bar plus R, Q bar plus R. Okay, because R bar whole bar is what? R. Then P bar plus R bar. P bar plus R bar. Okay, right. So here the question is regarding POS, and luckily here after doing the simplification, here actually original function is like SOP form, that 3 terms still we brought to 2 terms because of consensus law. Okay, right. After that we have applied the De Morgan's law, we are getting this product term become logical, this product term become logical. So here you are having what? One sum term, here also another sum term, those 2 are what? Multiplied. So it is the POS form. It is the POS form. So in this POS form you are having what? 2 terms are there, that's all. Number of sum terms present in the POS form, that is 2. Is it clear, Anish? Suppose for this question, instead of POS, if they ask SOP, suppose, now all of you give a try further. Just you can put as a note. whatever the function currently you got, consider this function and try to get in SOP. Yeah, no issue, no issue. Whatever the here expression you got, do further simplification and try to get SOP. For this question, why I have given 5-star rating? Because in order to get SOP form, like here according to this question up to POS only, okay. But for the same, for this equation, if you continue further, you will be getting SOP. In that SOP, how many product terms you are getting in the minimized function? For that, if you are getting correct answer, that means your whatever I told earlier, you can definitely attempt regarding Boolean algebra questions easily in the GATE exam, and in fact you can get the correct answer. Now all of you give a try. Whatever the equation you got here, do further simplification and try to get the SOP form. In that SOP form, how many product terms we are having. Okay, let us see here. So Q bar into P bar plus Q bar into R bar, then R into P bar, we can write it as P bar R, any order fine. Then R into R bar is what? 0. So anyway here 0 you are adding, that means the final answer will remain same. So that is the reason I am ignoring for the time. So the moment here you are getting like this, Q bar P bar plus Q bar R bar plus P bar R. Okay, majority of the students in the GATE exam, like if the question is whatever the function they have given, if they ask you that identify the minimized function in SOP form, in one of the choice they will be keeping like this, and majority of the students they may choose this is the final answer. But see, just now only we have discussed which law? Consensus law. That is the Brahmastra for Boolean algebra. Whenever you feel that, whenever you are getting 3 terms like this, sir, we cannot do further simplification just by observing the common terms or any manner. If you feel like that, only one weapon that is there with you, that is the last trial, that is the consensus law. With the help of consensus law, if there is a possibility to bring 3 terms into the 2 terms, do it. If not possible, then definitely that itself is the minimized function. Okay, this is the most important. That is the reason why I mentioned here excellent question, 5-star rating, actually for the SOP form. Okay, here before discussing SOP, just for this question I have asked POS, but with the help of this question I want to give the conclusion point with respect to SOP. Yes, very good. Now just observe here, in this case Q bar is present here and P bar is present here. In this particular term, the variable R is missing. So that is present here normal form, and the corresponding complement form is present. In this case, this is the redundant term. That's all. So you are getting the minimized function as Q bar R bar plus P bar R. So in the SOP form, this is the minimized function. In the SOP, the number of product terms also we are getting 2. This is a very, very interesting question. Before applying De Morgan's law, we have applied consensus law. Okay, and if the function they are asking SOP form in the minimized form, then once again in this process, after you got like this, you will be continuing further. There also you are supposed to apply one more time consensus law. Then only we can bring 3 terms to the 2 terms. Okay, I hope all of you liked this question, and I hope all of you felt this is a very, very interesting question. Okay, right. Because for any other law like distributive law or taking the common term or De Morgan's law, remaining all the basic rules and laws that anyone can easily apply, no doubt about it. Only thing, whoever know the basics and regarding those laws also, how to apply, by following which step you can get the answer quickly. Those logics, whoever can know, definitely they can answer the questions in less time. But otherwise, other than consensus law, with the help of remaining laws, whatever you have studied in the Boolean algebra topic, definitely with the help of that, most of the students are getting the answers correctly only. But some students can get the answer quickly, or some students can take more time. Okay, but if you want to get the answer quickly, whatever the conclusion points are there, basics are there, if you have observed while solving the questions, if you are able to apply, then definitely you can get the answers in less time. And in the entire Boolean algebra concept, the most important thing is consensus law, because no one will give the hint. No one will give the hint. You yourself should create the hint regarding consensus law. At least now, even though you forget, or even though you felt that, sir, we cannot apply or we cannot do further simplification, then that time I told one Brahmastra is there in second chapter, that is consensus law. Okay, with the help of that law, wherever there is a possibility, you can bring 3 terms into the 2 terms, you can do. Otherwise, that itself is the SOP form. That's all. Okay. Yes, very good. Okay, regarding our test series plus program, earlier I have already informed in the beginning of this session. Okay, whoever not enrolled at our IMS Gate Academy, okay, for those students, whoever self-learning program, whether whoever doing the gate preparation by themselves individually, or whoever might be preparing from other coaching institute, okay, by this time, whoever thoroughly prepared, now this is the time you pupil, just like in this particular session, whatever the questions here till now we have discussed, of course we are going to discuss even variety of questions in this session and continuation tomorrow session as well, like this interesting questions. See, even though you are good at concepts, but the most important thing, while you are applying those concepts in order to get the answers, okay, that time even though you are good at concepts, but still there is a scope that you are still, even now you are doing somewhere silly mistakes. So in order to identify where there are the silly mistakes are there, if you can identify as early as possible, definitely you can overcome those kind of silly mistakes in your actual GATE exam. For that reason, I am recommending this test series plus program. So all the students, okay, whoever not enrolled for test series plus program, so kindly enroll as quickly as possible, because 20% offer is there. So regarding the Google form link already provided in the description of this particular video. Okay, right. Yeah, we'll continue further. So in this question, you are having f of PQRS. Okay, for that function, they're asking the simplified function. You are having 4 choices. All of you give it a try. Whichever method you are comfortable, you can do it. Sorry. This is also one more excellent question. Yes, very good, Tarun, very good. See, here in this particular function, you are having sigma m and then you are having don't care terms also. Yes, very good, Anish. So whenever you are having min terms, in respect to min term positions, you can place output as 1. Whenever you are having don't cares, in respect to don't care term positions, you can represent X symbol. Yes, very good. All of you are getting correct answer. Very good, Medha. So here, since it is a function of 4 variables, okay, whenever you are having the don't care terms, definitely you can use K-map, okay, in order to get the minimized function. Okay, right. So since it is a 4 variable function, you can consider 4 variable K-map, and for the given function, whatever the min term numbers you are having, accordingly you can place the respective min term positions output as 1, and similarly corresponding don't case you can represent X symbol in this particular K-map. Okay, I hope all of you got the same K-map for this particular function. Okay, whoever got different or whoever having confusion, sir, how to place this K-map regarding output ones or don't care terms, you can mention the chart, I will clarify. So for the timing, I am assuming that everyone got the same K-map for this particular function. Okay, right. Now after that, here like for the timing I am discussing one method, after that I will discuss second method. That second method is the easiest method. Okay, that is the reason I have mentioned for this question excellent. Okay. So here first of all, if you observe in this K-map, like if you treat don't care terms as ones, okay, because of that if you are able to get the minimized function further, then you can treat those don't cares as ones. Okay, right. Say for example, okay, say for example here these 3 don't cares, if you are assuming ones, then we can do combinedly grouping of 8 ones here. We can do combinedly grouping of 8 ones. Okay, so for these 2 rows, p value is 0, that means p bar. Similarly, if you consider these 2 don't case and these 3 don't case as ones, then once again you are getting one more combinedly grouping of 8 ones. Okay, like this. Row 2, row 3. Row 2, row 3, you are having q value 1, p, r, s, those values are changing, it won't come in the final answer. Next, up to here we have done. Next, okay, now if you observe here you are having 2 ones. Okay, so these 2 columns we can do combinedly grouping. These 2 columns we can do combinedly grouping. Right. Now for these 2 columns, r value is 1, that is r, and here single 1 is left over. Now first column and last column are adjacent only, so we can do grouping of first column and last column. So from here you are getting s value is 0, that means s bar. Okay, for this K-map total we got 4 groupings. Whether all the groupings are compulsory or not in this K-map? Yes, all the groupings are compulsory. Okay, in fact we have covered all the ones. Yes or no? Right. So just observe, in order to cover this particular one, this blue color grouping is compulsory. Okay, in order to cover this one, this blue color grouping is compulsory. Right. Similarly, in order to cover this one, this grouping is compulsory, and similarly with respect to this one, this grouping is compulsory. In that manner you can verify whatever the groupings you have drawn, whether that grouping is compulsory or not, in order to decide with respect to any one in that grouping, except that grouping, if there is no other grouping, that means it is a mandatory. That's all. Okay. Now whatever here we have got, we have to sum together. Like here you are getting p bar plus q plus r plus s bar. Yes, that is there in option B. P bar, S bar, Q R. Okay, right. Now for this same question, actually if you are solving the question with respect to min terms, you are getting the answer correctly, but it is taking more time. But the same question, if you want to answer the question in less time. Now no need to follow this much. It is very simple. For any question, when you are solving with respect to K-map, whether we have to do the simplification with respect to like ones or with respect to zeros. Okay, so it is very simple. Whenever the question is like SOP form, definitely you have to do the simplification with respect to min terms. Whenever the question is regarding PYS form, definitely you have to do the grouping with respect to max terms. But whenever they don't mention anything, either SOP or PYS, or they have given complete freedom for you, or by observation of choice also you will be getting a hint. By observing choice also you will be getting a hint. Here in this case, if you observe, in all the choices for this particular question, if you observe, all the choices are in which form? Can you identify for this question? Just by looking at the expression. Actually here you are having what? Max term only. Only one max term is there. Yes or no? That is a hint point for this question. You can observe. Among the variables you are having logical, and in every option you are having 4 letters, and it is a function of 4 variables. That means number of variables, number of letters match, then the respective sum term or logical term is nothing but max term. Okay, so only one max term is there, that's all. Okay, now that is the hint point from this particular diagram, that's all. Okay, so the moment you have placed ones and don't case like this, okay, once again the same graph I have shown. Now here in this question, like you just focus with respect to zeros. Here adjacent to 0, there is no other 0 or there is no other don't care. That means this in itself we can do grouping, that's all. Okay, when you consider only that particular max term, that's all. Here like P value 1 complement, Q value 0 normal, and then R value 0 normal, and then S value 1 complement, that's all. That's all. Okay, I hope it is clear for everyone. Okay, if you want to solve the questions in less time, especially when you're having choices, see, once if you understand the question, what they have given and what you are supposed to calculate. Okay, if the question is NAT, definitely you can solve whichever approach you are comfortable, either conventional approach, shortcut. No issue at all. But whenever the question is MCQ or MSQ, definitely you are having the choices. Have a look at the choices once. After that, you can decide with the help of which approach you can easily get the answer. Definitely the choices are giving the hint for you, that's all. Just by observing here choices, in every choice you are having only one max term. Suppose let us consider in like whatever choices you are having, like 2 max terms multiplied or 3 max terms multiplied, that means pi capital M you are having, or even in the simplified form like sum terms multiplied, that means PYS form. That means you have to do grouping with respect to zeros. But for this question, since by observation of each choice you are having only max term, that max term itself, that means only 1 0 is sufficient. So in fact in this entire K-map, other than this cell, remaining all the places either you are having 1 or don't care, but only one place you are getting 0, definitely that itself is the answer. Okay, so even just why I discussed this method, it is just to give one conclusion point. Whenever for any question regarding this particular chapter, after doing the simplification, whatever the simplified expression you are getting, suppose if you are getting slight doubt or confusion is there whether your answer is the simplified or not, if you want to verify, you can verify with the different method, that's all. Say for example, when you consider min terms, whatever the function you are getting, similarly with the help of pi capital M, when you do the simplification, ultimately those two functions should be equivalent if you do further simplification. Okay, right. Yeah, next question, MSQ. All of you give it a try. I hope everyone will get the correct answer for this question. Okay, this question is MSQ, either one option or more than one option can be correct. This is a very, very important concept regarding prime implicants, essential prime implicants, redundant prime implicants. Okay, this concept is very important for all the 4 branches: EC, electrical, instrumentation, computer science. In this question, 2 choices you are having regarding number of essential prime implicants, 2 choices you are having regarding number of prime implicants. All of you give it a try. Even some of you, even now you are having slight confusion. At least with the help of this question, you are getting the clarity regarding this particular concept. Yes, very good. All of you are getting correct answer. Very good. Excellent. So whatever the function here you are having, for this function, it is a function of 4 variable. You consider 4 variable K-map and place the ones in the respective minterm positions. I hope all of you got the same K-map for this particular function, right? After that, whenever the question is regarding prime implicants, essential, redundant, etc. Okay. So do all the possible groupings of adjacently placed ones in decreasing powers of 2. Say for example, in this K-map, we can do grouping of 4 adjacently placed ones. That is the only highest possibility for this question or for this K-map, right? So you start from highest, whatever with the highest possible, you start from there. After that, you can do all the possible groupings with that, and then after that, if still, like if few ones are left over, then you can go for lower order. Okay, say for example here we can do corner 4 ones together, we can do one grouping. Okay, that is one grouping. Now 4 corner ones, when you have done the grouping, like for this grouping, you are for this particular question, no need to write the terms, just you can give the numbering, that will be sufficient. But with the help of this question, I want to give the further conclusion point. That is the only reason I am writing the corresponding product terms. Okay. So here B bar, okay, here B bar, since B value is 0, and then column wise D value is 0, D bar, B bar, D bar. Okay, then here first column and last column both are adjacent, so we can do grouping of 4 ones like this. Okay, so for this particular grouping of 4 ones, row wise A value is 0, that means A bar, then column wise D value is 0, that means D bar. Okay, A bar, D bar. Then okay, now here you are having 4 ones. We can do grouping of these 4 ones. For this grouping of 4 ones, row wise you are getting A value is 0, that means A bar, column wise, sorry, A value is 0, A bar, B value is 1, B, A bar, B. Then here you are having 2 more ones. Here we can do combined grouping of 4 ones, right? From here you are getting row wise B value 1 and column wise D value is 1. Okay. So in this way, for this K-map, only grouping of 4 adjacently placed ones possible. Like that, total you are getting 4 groupings. So from each grouping, whatever the product term we are getting, so we will call initially all of them as prime implicants. Okay. So that means here we are getting 4 prime implicants. Okay, for this question, number of prime implicants are 4. Number of prime implicants are 4. Now we will decide among all the groupings, whichever groupings are mandatory or compulsory, the respective product terms which we got, we will rename as essential prime implicants, or the respective prime implicants we are renaming as essential prime implicants. Now just observe, in this entire K-map, okay, with respect to this one, sorry, yeah, with respect to this one or with respect to this one, the grouping of 4 corner ones, it is a mandatory. That means this is the essential. This is the essential prime implicant. Similarly, you can observe here with respect to this one or with respect to this one, this grouping is compulsory, mandatory. So that is also essential. Okay. Now you can observe other two. What is happening? Like you have done grouping of 4 ones here. Suppose the momentarily, suppose you not done grouping here. Example. That means these 2 ones are having different grouping. These 2 ones are having different grouping. That means whatever the 4 ones here you are getting after doing the grouping, those 4 ones are already having other pair. That means this grouping is not at all compulsory, right? Okay. Similarly, one more grouping. Here you are having 4 ones. Suppose you haven't done this grouping. Suppose then these 2 ones are having one grouping. These 2 ones are having other grouping. That means whatever the 4 ones here you are having, even though if you not done this grouping, all the 4 ones are covered with other groupings. That means this is also not compulsory in the final. That's all. Now, among the 4, 2 are compulsory. Okay. Among the 4, 2 are compulsory. So, number of essential prime implicants we got 2. So, the moment you got up to here, number of prime implicants are 4. That means option B is correct. Okay. From here, option B is correct. Next, number of essential prime implicants are 2. From here, you are getting option C is correct. Okay, the moment option B is satisfying, obviously D we can eliminate. Similarly, option C, if it satisfies, option A we can eliminate for this question, because 2 choices are regarding number of prime implicants, 2 choices are related to number of essential. Okay, right. Up to here, everyone done correct, very well. Okay, now just I want to give one conclusion point with the help of this question. That is the reason I have written the corresponding product terms. But when you are solving this question in the GATE exam, if the question is like this, just you can give the numbering, that's all. For every grouping, you can give the numbering, like 1, 2, 3, 4. Among those 4 groupings, whichever are compulsory, those are essential. Okay, now suppose example, whatever the 4 terms here you got, after like from each grouping, whatever the terms you got, now I am considering every product term. Say for example, suppose if I give the one function like this, b bar d bar, okay, then bd, after that, okay, here I am considering these 2 also. Suppose a bar b plus a bar d bar, a bar d bar, just for note point. Okay. Okay, once again I am writing the entire expression as it is, like b bar d bar plus bd plus a bar b plus a bar d bar. Okay, I will be discussing. Okay, I am just keeping the pause here. Before that, suppose for the same question, if they ask you the minimized function, so in the minimized function, how many product terms you will be getting? Okay, you can answer this one question, and one more question is, for this particular given Boolean function, how many possible minimized functions we are having? 2 questions I have asked. The first question is, in the minimized function, how many product terms we are getting? That is the first question. You can mention answer in the chart. Okay. Second question is, for the given function, how many possible minimized functions we are having for this question? See, while you are writing the minimized function, first of all you are considering what? Essential prime implicants? Yes or no? The minimized function, you will be having essential prime implicants. After that, if required, other prime implicants you are considering. That's all. Okay. So, minimized function, so essential prime implicants I am considering like b bar d bar plus bd. b bar d bar plus bd. Okay. After that, what we are checking. Okay, see, when you have got these two are essential, after that what we have to do, very simple, whatever the product terms here like b bar d bar that you are getting because of the grouping of these four ones. Okay, you can put the tick marks just for reference. Okay, next bd you are getting by doing the grouping of these four ones. Now just cross check. In this K map, total you are having like 4 plus 4, 8 plus 2, 10 minterms you are having, or 10 ones you are having. Out of 10 ones, with the help of these two groupings, we are able to cover only 8 ones or 8 minterms. That means 2 minterms or 2 ones are not covered. Just observe, these 2 ones not covered by this essential nor covered by this essential. Now in this case, in order to cover these two ones, you are having two choices for this K map. Either some of you might have done like this grouping, that is one possibility, or some of you might have done like this grouping. That means for this question, 2 equivalent minimized functions you are getting. Okay, for this question you are getting two minimized functions, both are equivalent. Suppose if you have considered this blue color grouping, accordingly you are getting a bar d bar. Then if you have considered this one, a bar b, a bar. Okay, now it is very simple. Whenever you are getting more than one minimized function, in all those minimized functions, whichever terms are common, those common terms are nothing but essential prime implicants, that's all. And whichever term is varying, that is like selective prime implicant. Okay, in the minimized function, we should not consider all the 4 terms. The reason is, when you are able to get the minimized function with the help of 3 terms, the other 4th term is what? Redundant. Okay, so for this question, you are getting 2 equivalent minimized functions. Okay, in each minimized function, you are having 3 product terms. Okay, I hope it is clear for everyone. Now, I am coming back for this particular example. Suppose somehow other, instead of given like K map, suppose you are having the function like this. Okay, right. Either like this you are having, or somehow other after doing few steps simplification, somehow other you got like this. Okay, and if the question is MCQ, then definitely among the 4 choices, only one equivalent minimized function you will be having, right? So say for example, some of you followed like this, because of that you are having like this, or some of you followed like this, because of that you are getting like this. If the question is MSQ, then definitely you have to choose these 2 options, because you will be asking the question, you will be getting a question in such a way that identify the equivalent functions for the given function, right? So then you will be selecting. But if the question is MCQ, suppose you got like this, unfortunately that is not there in the given choice. Instead of that you are having like this, or similarly you might have got like this, but unfortunately instead of this you might be having like this. That time it is very simple, no need to get panic. If you followed the procedure correctly, definitely your answer is correct. But only thing for that question, because you are having more than one minimized function, because of that reason whatever the answer you are getting, that is not there. That time very simple, what you can do, like say for example, let us consider that you got like this, but somehow instead of this, in one of the choice you are having like this. It is very simple. First and foremost you got 3 terms. Now just observe the choices, whether any choice is there 2 terms or 3 terms like that. Suppose if any 2 terms is there, just verify. Okay, so this term matching, but this term is not there. So this term anyway we cannot do for this particular question, we cannot do further simplification, because we cannot apply consensus law here, right? So definitely 3 terms should be there. That means you just verify the choices in whichever choice you are having 3 terms. And now let us consider only one choice is there, example. Then in that choice just observe the common terms. Suppose b bar d bar matched, bd matched. Now no need to verify regarding these 2 terms. Now instead of a bar d bar, if a bar b is present, example, now what you can do, whatever the term is present in that choice, that term you can append here, that's all. Okay, that is the case here I have done. Okay, say for example, first equation I have considered up to here, and I have added according to the choice that one. Similarly, suppose you got like this, but unfortunately in one of the choice like this is there. So that term you can append, that's all. Okay, after that, how to identify whether that choice is correct or not? Simple. Say for example, you got like this, but choice is there like this example. Okay, so that means you want to eliminate this one. Okay, in this case you want to eliminate. So now just observe, a bar is present here, d bar is present here. Now just observe these three terms. With respect to these three terms, a bar present here, d bar present here. Here missing variable is what? When you look at these three terms, b is missing. That is present here, normal, and corresponding complement present here. In that case, this is what? Redundant? Yes. Okay. Similarly, in this particular example, suppose I want to, okay, you got like second expression, but unfortunately this is there, a bar, d bar, suppose. Okay. So in this case, you have to eliminate this one. Okay. A bar is there here, then b is present here. B is present here. Now just observe these three terms only. Just observe these three terms. Here missing variable is what? D, that is present here, normal, and corresponding complement is present here. Okay. So that means this particular term is what? Redundant. So now you are getting like this choice. Okay. In that manner you can verify. In majority of the cases, the minimized function will remain same. Either it can be SOP or POS. If you do further steps, definitely it will be equivalent. But in few cases, you may be getting more than one equivalent minimized function. That time you can follow this logic with the help of consensus law. You can trace out whether that given choice is correct or not. Okay, I hope it is clear for everyone regarding this one. Okay, till now whatever the questions we have discussed, the questions related to first chapter and then second chapter. Now we are going to discuss the questions related to third chapter. Okay, so all of you give it a try. In this question, you are having 2 input XNOR gate. For that, you have to apply dual, and after applying dual, whatever the 4 choices here you are having, whichever choice are equivalent, that you can identify. This question is MSQ. First of all, tell me, dual of XNOR gate is what? Dual of 2 input XNOR gate. In general, XNOR gate are complement each other, but for 2 input case, it will satisfy one more relation. What is a dual of 2 input XNOR gate? I hope all of you can answer. No, yeah, dual of 2 input XNOR gate, that is XOR gate. Very good, Anish. In general, XOR gate are complement each other, but only for 2 input case they are complement each other, they are dual to each other as well. So in this question, since they are asking dual of 2 input XNOR gate, that is nothing but A XOR B, A XOR B. So A XOR B we can write it as A bar B plus AB bar, A bar B plus AB bar. So that is there in option A. So as of now, option A is correct. Right. Then regarding option B, if you observe, you are having in POS. Okay. So see, it is very simple. From this equation, you can write like that, or otherwise, for this equation, if you do simplification, if you are able to get this one, then B is correct. Okay. Right. So for the time being, earlier we have discussed what? Distribute law. Now when you are having the terms like this, okay, now we can apply transposition law. While applying transposition law, very simple, like A bar plus A, when you are considering, you are getting one, that combination you can avoid. Now you can consider like this. Then you are getting what? A bar plus B bar. So the moment you got one pair like this, now leftover terms you can consider A plus B. Yes, now you can verify, yes, A plus B into A bar plus B bar by using transposition law. So here option B is correct. Now all of you verify whether C and D are correct or not. Yes, very good Medha, very good Anish, Phonics, yeah, very good. All of you are getting correct answer, very good. So first write the variables order A, B, C. Here the first term is A bar B. That means A value is 0, B value is 1. Regarding C, 2 combinations, 0 or 1. So that means you are getting, when you consider 0, M2 you are getting, when you consider 1, M3 you are getting. Okay. Next, another term AB bar. A value 1, B value 0. Regarding C, two combinations. It can be 0, it can be 1. If you consider 0, 100 is 4. If you consider 1, M5. So 2, 3, 4, 5. Yes, 2, 3, 4, 5 you are getting. Obviously, remaining combinations are what? Max term. Okay. So from here we are able to decide C and D are correct. So for this question, all the 4 choices are correct. Yeah, next question. So first of all, tell me what is this overall circuit represents which logic gate? You might have studied in your, like while you prepared for gate exam regarding digital circuit subject. So just observe this part of circuit, overall circuit, what you can write, like y equal to in terms of A and B. Once if you catch that one, after that you can easily solve this question. I hope all of you studied implementation of logic gates using NAND gates, similarly implementation of logic gates using NOR gates. Okay. So you are having 4 NAND gates like this. This overall circuit is nothing but XOR gate. Very good, XOR gate. So here that is the hint point. Once if you got that one, after that you can easily solve. Otherwise, whoever not traced, okay, they might be solving step by step and then it will take some time. Okay, definitely more time, but still you will get correct answer. But with the help of this question, I want to give one conclusion point that implementation of XOR gate using NAND gates. Okay, I hope all of you are familiar. With the help of 4 NAND gates, we are getting XOR gate. Okay, now here you understood this overall circuit is XOR. Now you can verify among these choices which one is correct. So here you are having A waveform like this, B waveform like this. Simple. Here A value 0, B value 0. Here A value 1, B value 0, like that. Generally we are formulating the truth table, but here you are having the timing waveform. With respect to XOR gate, among these 4 choices, whichever is correct as per the given A and B waveforms. See, just have a look at the waveforms. See, in whichever portion waveform pattern is same, that portion you no need to verify. Wherever the pattern is different, say for example here all are zeros, no need to verify. Here all are ones, no need to verify. Here you can observe 2 choices you are having 1, 2 choices you are having 0. Okay, this pattern you can observe. Yes, very good. All of you are getting correct answer. Option C is the correct one. Very good. So here for the time being, here I am considering like 1 case. 1 XOR 1, that is 0. Yes, here we are getting, that means here A and D we can eliminate. A and D we can eliminate. Okay, next. After that, among BC we have to verify. Here pattern is same, here pattern is different. Now this combination I am considering 0 1 case XOR, that means 1. So here option C will be correct. So we can eliminate B. Okay. So the first observation point, this overall circuit is nothing but XOR. After that, among the waveforms, in whichever portion you are having different, that combination you can consider. That's all. Okay, next question. So regarding logic gates, 2 variety of questions will come. Okay. So one variety they can give like this circuit diagram, they can ask the simplified output expression, or in order to get the output value 1 or 0, what should be the input combinations, etc. Okay, but for the time being, I have covered in another way. Okay, I have covered with respect to timing diagram. Now, one more important question or model regarding logic gates, that is regarding minimum number of NAND gates or minimum number of NOR gates for implementing so and so logic function. Okay, right. So for this question, you are having 4 variable came up like this. Okay, here regarding x anyway, you know that is a don't care term. Now the question is the minimum number of 2 input NAND gates required. The minimum number of 2 input NAND gates required to realize this particular function. And the most important thing, while answering these kind of questions, you should read the context of the inputs also. What information they have given regarding inputs. Here in this question, they clearly mentioned complemented inputs are not available, not available. That means whenever you are getting complement version, definitely you have to generate. Okay, but in some question they can give inputs are available in both normal and complement. Accordingly, according to the context of the question, you can answer may vary. That is very important. So first of all, tell me, whenever the question is regarding NAND gates, the simplified function you should have in which form? The simplified function you should have SOP or POS, so that we can easily implement by using NAND gates. All of you tell me. You can mention the chart. In order to implement by using NAND gates, the simplified function you should have SOP or POS. Yes, obviously SOP, so that you can easily implement by using NAND gates. So that means for this particular K-map, do the grouping with respect to ones, that's all. Yes, very good, very good. Do the grouping with respect to ones. So here we can do combinedly grouping of 8 ones, right? So from this grouping you are getting column wise A value is 1. Next, here after that one more possibility is grouping of 4 ones like this. Okay, so for this grouping you are getting here B value is 0, that means B bar, and then here C value is 1, C. Okay, so these are the only 2 groupings that are possible, right, with respect to ones I am talking. So those terms you can sum together, that's all. So here we are getting A plus B bar C, A plus B bar C. This is in SOP form. Now we can easily implement by using NAND gates. So in order to find out how many NAND gates we require, now you can put 2 times complement, and for inner complement you can apply De Morgan's law. First term complement, logical and second term complement, and then keep external complement as it is. Now just look at this expression according to this context. How many 2 input NAND gates we require? See, in this question complement inputs are not available, not available. That means we have to generate. Okay, so here A bar how you are getting? For 2 input NAND gate, if both the inputs are A, then you are getting A bar. That means we require 1. Then here for B bar also we require 1. Okay, after that B bar and C you are passing through 2 input NAND gate, and then you assume this is like Y1, this is like Y2, Y1, Y2 whole bar. So that means we require 4. Okay, we require 4 2 input NAND gates. We require 4 2 input NAND gates. Suppose for the same question, if they mention that inputs are available in both normal and complement forms, then what will be the answer? Same question only. Whatever the equation here you got, exactly same equation you can consider. Now just look at this equation, but only context only I have modified. Inputs are available in both normal and complement. Now what will be the answer? Just look at the same expression according to the current context. Inputs are available in both normal, complement. How many NAND gates we require? See, it is very simple. See, A bar already available, B bar already available. We no need to generate, that's all. After that here 1, that's all, 2. Okay, I am not writing completely. Since I have given the hint, I hope all of you understood. So here generally for any circuit or system, if they don't specify inputs are available in which form, by default they are available in the normal form, unless otherwise they are clearly mentioning that inputs are available in both normal as well as complement. That time only you no need to generate. Just like for C, you no need to use any logic gate. In a similar way for A bar, B bar, no need to use any logic gate. Here 1, that's all, 2. Okay. Now consider the same question same question. Suppose if the with respect to first context, that means complement inputs are not available, that time if they are asking the question with respect to NOR gates, the minimum number of 2 input NOR gates required. Same question only, whatever the function here I got minimized function, just for reference I am writing a plus b bar c. Okay. Now actually this function is what? SOP. But whenever the question is NOR gates, we have to bring the function into POS, okay, so that we can easily implement. Now by using distributive law, we can bring to the POS. So we are writing this function as a plus b bar into a plus c. Now this is in POS form. Now we can easily implement by using NOR gates. Okay, just like the procedure here we have told 2 times complement, exactly similar procedure. So apply De Morgan's law for inner complement. You will be getting first term complement plus second term complement, and then keep external complement as it is. Here a plus b bar. Now look at this expression. According to this context, all of you answer how many 2 input NOR gates we require. Here the context is what? Complement inputs are not available. Okay. Yes, very good phonics, very good. See here for b bar we require 1, then a plus b bar whole bar second, then a plus c whole bar third, for this third, and then consider this is like x1, this is like x2, x1 plus x2 whole bar. We require 4 2 input NOR gates. Yes, very good Anish. So answer for this question is 4. Suppose same question, if I am modifying the context, like inputs are available in both normal complement, then how many 2 input NOR gates we require? Same equation, just have a look at here only and tell me the final answer. So in this way, while you are answering these kind of questions, the context of the question is very important. According to the context, the answer may vary. Even though you are good at solving the question, but in hurry mode in the GATE exam, if you are not carefully observing what kind of information they have given or according to what context they are asking, if you are not focusing the main keywords, damn sure you may get the wrong answer. That is the reason, at least with the help of this GATE score booster session, you are getting to know in each and every concept of digital circuit where in general majority of the students may do silly mistake. At least you are getting the alert so that you people can avoid these kind of silly mistakes in your actual GATE exam. Okay, right. Yes, very good, 3. That's all. Here B bar already available just like A and C. Okay, so 1, 2, 3, that's all. So for this question answer will be 3. Simple logic, whenever the question is regarding NAND gates, you should bring the function into SOP so that you can easily implement. Similarly, whenever the question is NOR gates, you try to bring the function into POS form. That's all. And according to the context of the inputs in which form available, according to the answer may vary. Okay. Right. Now, this is the last question regarding today's session. I hope all of you can answer this question correctly. Just like earlier questions also, many of you are able to attempt the questions correctly, and some of you might have got few questions correctly and few questions wrong, no issue. Okay, but this is the dead easy question I am giving because this is the last question for today's session. I am giving very great chance for everyone in order to answer this question correctly. Yes, very good Anish, very good. Even other students also, please give a try. This is the last question for today's session. Yes, very good, very good. All of you are getting correct answer. So here in this question, you are supposed to identify the universal gates. Okay, you are very much familiar regarding NAND gate and NOR gate. These two gates are universal gates. Okay, now you can observe here at the input side bubbles are there. Okay, so that means if you are not comfortable regarding these bubbles, you can replace that bubble with NOT gate. That bubble with NOT gate. So that means if you are having A, B are the inputs, you are getting what? A bar, B bar. So now A bar, B bar you are passing through what? OR gate. Okay, so that means the expression you are getting A bar plus B bar. Now by using De Morgan's law, we can write it as AB bar. That means this gate and this gate both are same only. Okay, similarly, okay, whatever the logic here I have discussed, so based on that here we are getting A bar, B bar are the two inputs we are giving as input for AND gate. So we are getting A bar and B bar. By using De Morgan's law, we can write it as A plus B whole bar. That means it is a NOR gate. That means this gate and this gate both are same. Okay, only thing here inputs you are having normal form, but here inputs are like bubbles. Okay, the bubbles means active low input, simple. Okay, so for this question, all the four choices are universal gates only, A, B, C, D. Okay, so with this we have completed regarding digital circuit subject 3 chapters like number systems and codes, Boolean algebra and K-maps, and then logic gates. Regarding these 3 chapters, we have discussed variety of questions in this particular session, right? So similarly, on tomorrow's session, we are going to discuss the remaining 4 chapters. Okay, so all of you kindly share your experience. Whoever attended this session live now, you people can share your experience in the chat, and whoever watching this session later, those students can share regarding this particular session whatever the benefit that you have got in terms of number of questions that we have discussed, right, in this particular session regarding first 3 chapters of digital circuit subject, and whatever the in terms of knowledge or in terms of method of solving or in terms of like whatever something you learnt because of this session. Okay, definitely you can share that valid point in the chat or comment section, and whichever questions you like the most or you don't know earlier like the method of solving for that question, or at least with the help of this session you come to know that okay, at least you become perfect in that concept or method regarding that particular question. At least you can share whatever you want to share your experience from this particular session in the chat, whoever attending live now, and whoever watching this session later, they can mention in the comment section. Okay, right. So we have discussed variety of questions in this particular session. In a similar way, on tomorrow in the same time like 4 to 7 we are having for digital circuits second session. Okay, so this session is also common for all the 4 branches, but for CS branch up to 5th chapter whatever we are discussing, that much only for the gate syllabus. Okay, whereas for electrical up to 6th chapter, whereas for EC and IN up to 7th chapter. So tomorrow we are going to discuss the variety of questions related to combination circuits, sequence circuits, data converters, and then CMOS logic family. Okay, right. I hope all of you got benefited from this party session. In a similar way, whoever want to check their confidence, especially regarding the remaining 4 chapters of digital circuit subject, don't miss tomorrow's session. Okay, right. We'll meet you all in that session. Okay, so before ending today's session, I'm just giving few updates. If you already know, okay, you can, if you already joined our Telegram channel, okay, no issue, but whoever not joined, and at least you people can share this valuable information with your friends also, because regarding this Telegram channel, the link already provided in the description, it is free for everyone, anyone can join. Okay, and whatever currently you people are attending the live session, in a similar way, whatever the upcoming live sessions are there, that updates you will be getting in this particular Telegram group, and whatever faculties have written, okay, during the live session, especially whatever the classes currently we are teaching, okay, those lecture PDF notes also write immediately after the session over, our team will be sharing in this particular Telegram channel. Okay, and of course you will be getting all other important updates also. Okay, so all these benefits you are getting for free of cost. Whoever already by this time joined, fine, you people can inform this information to your friends as well. Okay, right. Yeah, thank you everyone. I hope all of you got maximum benefit from today's session, right? Yeah. Similarly, as I mentioned earlier also regarding this test series plus, this is the most important, because whatever the 21 questions in this particular session we have discussed from the 3 chapters of digital circuit subject, in the similar way you will be getting great command. If you want to get confidence and if you want to get the command over the subjects which you are preparing for the GATE exam, so definitely this online test series is going to help a lot. And even our previous year GATE question booklet is one of the amazing product that we are having at our IMS GATE Academy, right? So all these benefits you are getting, don't delay. So all of you kindly share this valuable information with all of your friends and juniors who are targeting for GATE 25 exam. Okay, they can enroll for test series plus program. 20% offer is there, but that offer is for limited period. Okay, yeah, thank you everyone. So I hope all of you got maximum benefit in today's session. In a similar way, we will be discussing variety of questions which are very much important for your coming GATE exam related to the last 4 chapters of digital circuit subject. So whoever missed today's session because of any reason, at least you people can inform to your friends and juniors. Okay, at least they can watch that today's session whenever they get time, and at least they can attend the tomorrow's session live. Okay, thank you everyone. We'll meet you all on tomorrow's session at 4 o'clock.